So, good evening, everybody. First of all, welcome to this workshop, which we have mixed as a virtual for the lectures and hands on training on 10th of March once you join us for the conference. We have made this session of virtual talk because we wanted that at least you should have some preliminary idea and you get more and more time for hands on training. The faculty we have chosen, they are best in their field of Ecmo as well as in the critical care. So I request all of you to take the benefit of this opportunity, ask questions, learn from the learned faculty. So you can modify your practices, you can resolve your queries, and you can learn much more about the ECMO management when you come across with these kind of a critically ill patients. So I'm happy that there are very good people have registered for the conference, and better best part is the faculty has given consent for these workshop to deliver the lecture online as well as giving the offline training. So this workshop will have 2 days online lectures, which will be including several topics related with the initial ECMO management as well as in some complicated situation like we will be starting with the basic ECMO, what is the philosophy, what are the different indications, what are the different component of ECMO, how we prepare the circuit, these kind of basic things, then how we make a team, how we allocate work to the others, and what are the different checklists we use, how we manage the anticoagulation, how we initiate, what we monitor, and then various components, blood component usage, management on ventilator, how we do the dialysis if required on ECMO, and how we wean and decannulate. So all these important aspects will be covered during the 2 days this online session. But I will request all the participants that ask questions as much as you can. You can use both the ways. You can ask questions after completion of the lecture of the faculty, or you can post a question in the chat box, and Dr. Suvir, Dr. Rakesh, Dr. Kapil, and Mr. Arvind is there to take these questions and ask the faculty. And Mr. Ali will, whenever he's available and his interconnection is good, he will keep giving his inputs. So best wishes, and I'm sure this workshop and the conference will help you to enhance your skills of ECMO practices. And I'm sure that you will have a much more learning during these sessions. Over to you, Dr. Suvir. Thank you.
Thank you, Dr. Vivek. Moving forward with the workshop and this, virtual lectures, I'd like to introduce Mr. Ali Borojadi Alawi. He is ECMO coordinator and director of ECMO at Shahid Lavasani Hospital, Iran, and Tehran. So I'll be playing his recorded lecture. I'll be sharing the lecture in a few moments.
Dr. Suvir is initiating the lecture. Just let you know about Ali. He's basically a ECMO coordinator across the Iran. And he has really worked hard to initiate a ECMO program and running ECMO program throughout the Iran. So he's a very knowledgeable person and he knows his subject very well. So I'll be happy that you ask questions and he'll be answering you a lot of.
Thank you very much of the chairmans for invitation and giving the opportunity to speaking. My speech is today about the philosophy of initiation ECMO and staff model. My name is Ali Burujardi Alavi, President of Iran Sect and Steering Committee of SWAC also from Iran. Thank you of your kind attention to me. As you know, maybe that most centers that wanted to start initiating the Ecmo program, they face with the many challenges that mostly the people who are responsible to the running the Ecmo face with the many questions that should be answered before the establishing the programs. As the questions samples that they mostly face as community needed to assessment how to assessment the people who are working together. Administration support of this program is one of the most important. Business plan is another aspects, and staffing one of the most important part that today we want to speaking about is staffing and the models that people can use in the programs in the hospital or centers, equipment, staff educations, planning for education and increase the ongoing competency during the ECMO program, clinical guidelines and policy, quality and outcomes, and reimbursements. Now we focus on the staffing model. The models which is very popular and recommended is four types, which is based on perfusion based model, nursing based model, respiratory therapist based model, and hybrid models, which have been referred to the guidelines of the also about the people who can involve in initiation of ECMO and in duration and progression, which is mentioned here, the successful completion and approval School of Nursing with the people who have an RN and have certified to working in United States, of course, the people who are working in the respiratory therapy program, successful completion and accredited, and the people who come from a perfusion school and certification of the American Board of Cardiovascular, and the other physicians who are successfully complete the institutional training requirements or other guidelines according to the ELSO. Because the approved this basement of the model with the ELSO, we are speaking about how these four models can be give advantages and disadvantages when you wanted to start the ECMO program in your center. First, we focus on the perfusion-based ECMO staffing models, which the people who are very trained about the extracorporeal and mostly recommended that when you wanted to start your centers for ECMO program would be very helpful to use of the perfusion-based model, and then you start and doing the educations, you can change to the other models. And the perfusion base has many advantages, which we mentioned here, especially these people are trained for extracorporeal support most of the time. Many devices that will support many actions who is related to the extracorporeal is mentioned during the course and experience that they have. There are people who simple to train for make them adjustment to your ECMO program, and mostly they no need to ongoing competency training or maybe a little needed because at the daily practice they do all the time the extracorporeal circulation technique management, and when they shift to the ECMO system they save their competency and increase very fast. Therefore, rather than the other groups, you need less to do activity about the training competency. They are familiar with the emergent situation because most of the time they have practice at this situation in the OR, in the cath lab, in the emergency room, in the road, in the many places that they needed to work and have find many experience at this field. As you know, maybe there is a ratio between the patient and full-time employee, which is very perfect in the perfusion-based program because mostly they work with the same patients in the OR. One perfusionist with one patient. Of course, these types is may be different in the other centers or even other country. For example, in my country, mostly two perfusionists works in the OR uh, for the CPB and cardiopulmonary bypass, and maybe in the other countries there was other policies, but there is a largest ratio between patient and full-time employee because mostly they work one-one with the patients, and they feel comfortable if you have in your ICU, for example, 3 person on a ECMO, and they can take care of the circuit management and the extracorporeal control in the ICU. Therefore, is for them this is too simple and too comfortable to do this activity, and it is bring the largest patients to FTE ratio. Core knowledge that they have studied during the years of the schools is based on circulatory support and is help them to understand better your plans, better your program, and they have the highest productivity ratio when they're working in the system, and they are the advantages of perfusion-based model. But the perfusion-based model has some consideration or disadvantages that mentioned here. This model is very expensive because when your perfusionist wants to work in your system in the ICU, he or she should leave the OR and go into the ICU, and the models of works in the OR is cancelled or something else should do the job. Therefore, it is totally an expensive model because the character of the perfusion and the limited availability that they have in the most center. That in the next slide we show the comparison as a population of them. They can't float it to other service lines. They, for example, couldn't help the nursing for giving the drugs to the patient or something else. They are mostly work in the OR environment, and they are not too familiar with the ICU environments, and it's have bring some complications during the job, and they cannot provide duplicated nursing roles on the ICU. The next model is nursing-based Ecmo model, which have many advantages. As you know, they can provide one-to-one ratio. If you have, for example, 10 person in the Ecmo in your ICU, you can simply give 10 nurses to them for taking care because they are available and they are at your system or doing the care nursing, and if added some ECMO persons, it can take care of them because the large availability of labor pool that they have. This is less expensive rather than perfusion per productive hours, because when you separate the perfusionist from the OR, the job of the OR is stops and the job of the ICU is start, and the productive hours is is conflicted. Therefore, as this way, the nursing model is less expensive rather than perfusion model. They can be floated back to the nursing pool in every situations that happen in ICU. They are completely familiar with the ICU environment, setting, culture, relation between the people in the ICU that the perfusion team aren't, and they have different core knowledge. Even it's not exactly related to extracorporeal, but have many knowledge about the other area. But the nursing models have some disadvantage that we explain this at this slide. They are more complex and extensive training required because they are not familiar with the Ecmo characteristic and extracorporeal system. Therefore, the time and the model of the training is more complex and more extensive. At this way, this training should be more expensive rather than training for the perfusion team, and they also needed ongoing competency training during the job till that your center is established as a volume of ECMO that down and increase the volume, and they train more and more. But in the initiation, they need too much ongoing competency training, and mostly this model need an extra model, for example someone else near the job for better handling during the initiation period, and therefore is having disadvantages. And the another things which is very important in the nursing teams is when they are trained about the extracorporeal ECMO and the other extracorporeal support, and they mostly are very intelligent persons, they are very active persons, and this motivation them that to increase their quality in the upper level. Therefore, most nursing people that join to the training and be familiar with the principle of the extracorporeal are motivated to go to the upper grade. They wanted to go to the master science, to PhD, to practitioner, to increase the level and change the platform that they running the care on the ICU to the better positions. It's just look like a trampoline that when the nursing team joins wants to jump to the other higher level of the job. Therefore, it is called the retention, and it's very important things because you do many things, many expenses to train a nursing team, and after sometimes you lost them, they're going to the other job. And you should consider that there is many circulatory support system that to learning all of them is for the nursing teams which are not familiar with them, need many more works and training planning, and should keep the maintain competency on it. For the comparison between the nurse and perfusionist in Iran, I will say to you that nursing population, the full-time employee in my country is 125,000 people, which include OR nurse, anesthesia nurse, aid nurse, and 78% are ladies and 22% are men. 53 are employed in the governmental hospital and 47 in private charity or not working. As you consider that total population in Iran is 85 million people. Total perfusionists just now is 467, include the hospital-based trained with the board certifications and academic trained as a Master of Science. Full-time employee 347, and other are retired, case-based job or private. And if you look at this, one perfusionist is the ratio to the 26-7 nurses. As a comparison, you can see that how much the number of the nurses are and population are bigger than the perfusionists. And if you use this comparison between nurses and perfusionists in the USA, nursing population in the US is around 3,400,000 registered nurses and 2,700,000 in the field nursing job on job, and perfusion population is 4,200, some of for all the entire the country. Total population is 331 million people. Therefore, per 89 RN nurse, there is only one perfusionist. This comparison shows that how it's hard to changing the model from between the nursing and the perfusion team. And the respiratory therapist is another model that advantages is retention is much better than the nursing. They are accept the job and mostly don't like as a nursing to goes up level, large availability of the labor pool, least expensive than the labor force per productive hours rather than the perfusion, and nursing teams can have limited float capability with facility and integrated in ICU environment. They're familiar with them, and disadvantage, they are not training especially for extracorporeal support, mostly focus on the respiratory failure rather than cardiac failure. They need the ongoing competency training and cannot duplicate the nursing role. Smaller rather than perfusionists, the ratio between patient and FTE and expensive to train, and generally if you use only them for your Ecmo training, need to add another model to support them. And what's about the hybrid base, which is a combination of perfusionist, nursing, respiratory therapists together. That's have many advantages: the ability to flex in the staffing, large availability of labor pool. You can align the roles and the responsibility, collaboration and learning opportunity with the different disciplines. Perfusionists can learn to the other people. Nursing can do something inside the ICU. It can be least expensive model and can limited floated capability with the facilities. And you should know in the hybrid, mostly you set the right person in the right job. Therefore, you can reach to the to your aim, which is successful patients care. And this is the most important things that you should consider. But disadvantage of this model is need more training. A staffing schedule is very difficult. Some to getting people together as a discipline is very complicated because they have several experience, personality, knowledge, and ongoing competency training is necessary for this model, and this can be expensive if the retentions happen in the system that you starting. Overall considerations is that the patient status and value is very important things that you choose your staffing model for your center when you wanted to initiate. Initiate training of non-perfusion staffing roughly have $2,000 per employee. That's a full-time employee. It's too much, and only the perfusion need is less and cheaper training route. With ongoing competency training and unproductive time for non-perfusion staffing model, and there is about a 15 to 25% loss of hours annually per FTE, because when you send them for the learning or training course, they lost the job doing, therefore, and because its time is longer, therefore you needed to cover with the other people, and this increase the cost. Coverage is 24/7, 365 days. Even when you have no patients on a ECMO, it can be too much costly. ECPR is a challenge there, and retention is the single most important variable on ECMO staffing model that you should consider always. References is about Vanderbilt University, Perf Educational, Matt Vanderbilt, and other which was mentioned here. Thank you for your kind attention.
Thank you, Mr. Ali, for the nice lecture. It was very informative. And any questions or queries from the audience?
Fine. So good evening all of you. Vivek has already talked about the course, how the course is going to be, and then the conference for the next 2 days on 11th and 12th. 10th, you will be doing the hands-on practical, all aspects that will be done on 10th. So before that, we will be finishing the talk. This is going to be a mini course, because we cannot finish the entire Ecmo in 2 days time. So this is going to be a mini course. We conduct around 6 days course for of the Ecmo Society of India, dedicated course on Ecmo training. That will be 3 days online talks, and then followed by 3 days going to be on workshop. So 3 days you have to physically come to Bombay for the workshop, and there we do the detailed workshop program. This year we do twice a year in January and June, and it is an also endorse course. And this June it is going to be 5, 6, 7 June as the online talks, and then 10, 11, and 12 June as a hands-on. So we'll be coming here for 3 days. It will be from 8 to 6 only workshop. So we have to move in the different stations for first 2 days. That is will be on 10th and 11th, and 12th day will be a simulation and your exams day. So that is what usually we do for our also endorsed training course in the month of January and June. Okay. So now again in the conference for 2 days will be there are different sessions. I think some of you must have taken part in the quiz competitions also. The registration for the quiz is Vivek is still open. Can they register for quiz if someone is interested? I think Vivek is not there. So anyway, you can join if you are still interested to join the quiz. You can definitely join the quiz. Whenever the Arvind comes, let me know so that Arvind can start his talks. If it's going to take long time, I think I can start with the indications of Ecmo, and then let Arvind to talk. We can do in that way also.
I think that would be better if you start with the indications and then we'll take a sessions of Mr. Arvind. So we can save our time.
Yeah. So, Surveer, should I start?
Yes, sir. I'll just.
You can make me co-host so that I can start with my talk, so we can save time. Otherwise, it will be too late in the night.
Right, sir. Right, sir. So I'll just do a brief introduction. I'm Dr. Paneoza. He's intensivist and ECMO program coordinator at Vidhi Vinayak Hospital and Mumbai. He's very senior and dedicated and very experienced intensivist and ECMO coordinator. So over to you, sir. I'll just hope you can share the screen now.
Can you all see my slides?
Yes, sir.
Yes, sir, visible.
Yeah. Okay, so we'll go for what are the indications and criteria. I'll speak on that, and then we'll go for introduction about it. So the question is that in critical care, we have ventilators, we have inotropic agents, we have a lot of IVPs and other measures also like CRT, cytokine removal. So do we require any extra machine like an Ecmo? And does it really going to be helpful? And if at all it is going to be helpful, then when should we consider? So if you think about how your patients behaves in ICU and usually think how many patients, how they die, usually either they die because of the worsening and uncontrolled disease process and you are not able to control it. But that population probably is going to be less as compared to the population which is more, which is usually die of iatrogenic complications. So they come with some primary illness and you are able to manage the primary illness to some extent, but then they develop some secondary complications and we lose because of that. And probably the reason for all that worsening and uncontrolled disease process or even the iatrogenic complications are we are not able to support them adequately and safely. These are two most important words I would like to emphasize is you have to support them adequately so that they can maintain the body functions, but at the same time you have to consider the safety also. So both is going to be difficult. When we try to go for adequacy of the support, we lose the safety, and when we try to look for the safety, we are unable to adequately support them. And something like ventilator-induced lung injury or a lot of high inotropic support, so that has all these adverse effects. And then we would give a lot of fluids, so fluid edema, all organ edema, and worsening globals and regional tissue perfusion, and that all leads to iatrogenic complications. So how your ECMO is going to help, or what does ECMO do? It helps to sustain the life. It's just a replacement. So you are going to replace your heart and lung function with the ECMO. So it is going to sustain the life till the time you don't find out what is the cause in a case of cardiac arrest, and you can treat it. It maintains the gas exchanges, so it will take care of lung function. It maintains the mean artery pressures and tissue perfusion, and thereby takes care of the cardiac functions also. So it is an artificial heart and lung that functions can be taken care with the help of ECMO. So how does it help us? Is by maintaining the tissue perfusions and the circulation and gas exchange. What it helps is to it decreases the inotropic requirements, and thereby it reduces the toxic effects of the inotropics. It decreases the ventilator requirements, and thereby it reduces the incidence of villi. And all by doing all this, it gives rest to the heart and lung. That is most important. The organ which is diseased, it gives rest to the heart and lung. So ECMO, why? Because we want to give rest to the organs which is affected. Think about refractory RDS, think about cardiogenic shock. Are we able to do that? The answer is no. We are not able to, because if we try to go for adequacy, we lose the safety, and we try to go for safety, we lose the adequacy. So we are not able to do that, and we are not able to give the rest to the lungs, to the organs. So we make them to only work more and more. So we run behind the numbers and we forget the organs. So that's what which happens. In refractory ARDS, we try to maintain the saturation. So we go for high FiO2, we go for a high PEEP, we go for high pressures to maintain the minute ventilation and get rid of CO2. And in cardiogenic support, we go on very high supports of inotropics. So it's just like a slogging a dead horse. And that's where the ECMO plays a role. So ECMO is a replacement therapy, so it does not load the heart and lung, and you can able to take care of, give rest to the heart and lungs. So what you need to know is ECMO is not a treatment by itself. It's a mechanical assist device, which is rather a replacement therapy, just to sustain the life, to give rest to the organs, and to maintain adequate perfusions and oxygenations. So it is like a bridge to somewhere. Most commonly, the bridge to recovery. That is what we usually intend. It should be a bridge to recovery. And that's the reason we indicate more in case of acute cases where ECMO becomes a bridge to recovery, or it can be a bridge to a clinical assist device in a chronic lung disease or in chronic cardiac disease. It can be an assistant to assist for a bridge to assist device, or it can be a bridge to transplant. So all these cases of chronic diseases, it can remain as a bridge to transplant. And if you see the ECMO, how it has spread, it has got its indications in all of your ICU, whether you think of respiratory ICU, think of cardiac ICU, medical ICU, surgical ICU, emergency rooms, neuro ICU, NICU or PICU or transplant ICU, everywhere the ECMO has got its own role to play. So ECMO in a respiratory ICU is basically it helps to for an acute life-threatening and reversible cases which is not responsible to conventional and alternative therapy. So you tried everything and it's not helping, so it is going to be bridge to recovery basically in acute conditions, and it helps for both oxygen failure as well as ventilation failure or in case of combined. So you can give use ECMO for a hypoxia, you can use for type 1 and type 2 respiratory failure, hypoxia, hypercapnia, or when the picture is both mixed. So these are the different indications where any indication which causes hypoxia or hypercapnia and which is refractory to the treatment, you can consider that for the ECMO. So can be for ARDS, pneumonia, these are the commonest indications, status asthmaticus or pulmonary embolism, this becomes the commonest indications. Now, what will the criteria for a respiratory ECMO to be selected? See, usually you don't wait for a long time. So the indications is basically when the PF ratios goes less than 75%, okay, or rather now we are even started considering ECMO for when it goes to less than 100, we consider ECMO, or oxygen index more than 30, or Murray score is more than 3. These are the conditions where we can consider the patient for ECMO. A gradients we usually don't get, but if it is more than 600, hypercapnia with pH is less than 7.2. There can be a permissive hypercapnia, we can just wait, but if the hypercapnia which is causing the pH less than 7.2, we need to think about considering the patient for ECMO earlier. What are the exclusion criteria? When there's the irreversible disease, when the patient is on ventilator for more than 10 days. So when I say more than 10 days, it means more than 10 days of 5 ventilator settings. Why that becomes a relative contraindication? The reason is because this patient it's less chance likely that the lungs will recover and they will take a if at all recovers, it takes very, very long time, and they'll end up with transplant. So if you have a transplant in mind, and if that is a possibility, you can still consider patients on ventilator for more than 10 days. Otherwise, that becomes a relative contraindications. Any bleed which is not compressible, IC bleeds which is not going to be treatable, you should not consider ECMO. And unwitnessed cardiac arrest, you should not consider for ECMO because you don't know about the neurological status. In patient in the gross multi-organ failure, again, becomes a relative contraindication for ECMO. ECMO in acute or chronic respiratory failure, initiate early. That is most important because the more you put the patient on ventilator and the more the days patient remains on ventilator, the day the lung function further worsens, even the chronic lung function worsens. So it is always better to put the patient early on ECMO and then try to extubate them and manage them on BiPAP or something. Okay. And this is the statistics which says that for 2022, around 42,000 of adult ECMO has been done all over. Around 11,000 or 12,000 is in pediatric ECMO, and around 34,000 neonatal ECMOs is been done, with the survival rate ranging right from neonate around 80% up to 58% in adults. So the good survival chances with the ECMO in respiratory indications. Okay. And if it is the last 5 years survival, if you see the data from the ELSO, that suggests that more and more adult ECMO has been increased. So almost 28,000 in last 5 years ECMO has been done, and that is in adults. But the neonatal and pediatric indications or the number of ECMOs be done are much less in neonates and pediatrics. Okay. So in cardiac failure, any kind of cardiogenic shock which is refractory to conventional therapy, it can be refractory arrhythmias, it can be acute myocardial infarction, decompensated cardiomyopathy, myocarditis. So any of these which refractory cardiogenic shock can be considered for an acute recovery to the recovery. It is a potential reversible myocardial dysfunction that will be bridged to recovery, or if it is an irreversible case like in case of cardiomyopathy, dilated cardiomyopathy, it will be bridged to transplant. So when you consider ECMO here, when you are unable to maintain the hemodynamics with the Mean artery pressure is less than 70 in adults, with adult pediatrics 55, less than 40 in neonates. Most important is you have to go by the venous saturation and lactates. You have to go by tissue perfusion. Mean artery pressures can be maintained with the sympathetic overtone or with a lot of inotropic supports. But most important is the lactates and the tissue perfusion. The lactates are high and the venous saturation is low. You have to always consider patient report on Ecmo. And what is important is if the lactate is a rising trend. If the lactate increases by 0.75 millimoles per liter every hour, you should think about patient to put on Ecmo. And when your inotropic score is more than 20, consider patient for Ecmo. Okay. So most important is that you should always consider patient for cardiogenic stroke to be put on Ecmo before the patient goes into secondary damage. Before he goes to irreversible stroke or severe acidosis or multi-organ failure. And that is most important is. Usually we delay in initiating Ecmo and that will lead to not a good favorable outcome. If you consider the University of Michigan, according to them, if you see the cardiac index of less than 2 liters, when the patient start developing oliguria of 0.5 ml per kg per hour for 3 hours, they start considering that as a relative contraindications. So that is what is most important. One should know that you should start Ecmo early in the course of time. Yeah. And if you see about the cardiac Ecmos, number of cardiac Ecmos are gradually increasing in adults. Again, it is around 15,000 cases has been done of the adult cardiac Ecmo in last 5 years, and the survival rate is a little less in cardiac, around 40% to 60% from if you see from adult to pediatrics and neonates. But the number of cardiac cases are again now started increasing. In medical ICU, it is indicated for a septic shock, for a poisoning, and for hypothermic coagulopathy. Septic shock, it's going to be a little difficult to manage because the septic shock can be because of the peripheral vasodilation and capillary leak. So if it is a distributed shock, Ecmo does not have much role to play. But if it is a cardiogenic septic shock because of myocarditis or with the right heart failure or with the poor cardiac function, or if it's a mixed kind, then definitely Ecmo has got a better role to play. And the survival in chances in adults is around 20 to 30%. Pediatric 40 to 50% and neonates around 70%. So all these cases, whether it is dengue myocarditis, malaria myocarditis, or malaria adds with myocarditis, all they have got better scope to survive, and they used to consider Ecmo in these patients. Okay. Ecmo and poisoning. There are a lot of poisonings where the Ecmo has been used. In India, most of the commonest poison where Ecmo has been used is aluminum phosphide poisoning or cellulose poisoning. A lot of work is done by Vivek on that. He has got a series of more than 100 patients. And same thing in Gujarat also there are a lot of cases. And in fact, they have got much better outcome. Around 70% is survival rate. Ecmo in poisoning has to be considered because most of the patients are young and it's a reversible thing. You have to just take care of them for a few days and they give a better outcome. Ecmo for hypothermic coagulopathy, usually this is post-traumatic or patient goes into severe hypothermia and then keeps on bleed. Here, you have to just do whatever you do, usually passive warming of the patients, and that does not help to a great extent because you have to give a lot of blood transfusion, which is always cold in nature. So that does not help to a great extent. What you have to do is here, you can take the Ecmo, it is going to be a very short Ecmo for a few hours only, which is going to be heparin free. You can just do VV Ecmo in this, put a small size cannula, either double lumen or two sides. And what you need to do is you have to gradually warm the patient up. Once the patient is warmed up, the flow requirement is on 3 to 3.5 liters. And when the patient is warmed up, you can just get rid of Ecmo within next 2 to 3 hours. So you have to just, it takes 30 to 45 minutes to come to a normal thermia. Maintain for next another half an hour or 40 minutes, and then you can get rid of Ecmo. So this is going to be a shortest Ecmo where you can, and in other even procedures support, you can use Ecmo for the procedure support. Okay. Ecmo in pre and post cardiac surgery. Indications is post cardiac cardiogenic shock and for congenital heart disease with the pre-cardiotomy dysfunction. So you can use ECMO here for pre-support, let the patient to stabilize, and then post-ECMO, you can, even the post-surgery, if the patient has got a cardiac dysfunction, you can put the patient on ECMO. Okay. Many times after going on a cardiopulmonary bypass, patient develops some myocardial dysfunction that is because of either the inflammatory response or increased cross-clamp time or reperfusion injury or hypothermic injury. And because of that, they develop myocardial dysfunction. You have to support them post-op for a ECMO for a few days and probably they will recover. So again, the indications for ECMO is going to be the same because it's going to be cardiac ECMO. So most important, as I told you, is rising lactates of 0.75 millimole per liter becomes an indication for a cardiac ECMO. But when you consider the cardiac ECMO for a surgical patients, always remember that you have to think about it should be bridged to myocardial recovery, or it can be bridged to to a transplant. Because the patient is there's got underlying lesions and that is not treatable. In that case, you should consider this for the bridge to transplant. Okay. So ECMO can be again useful as some procedure support, like in case of complex tracheal reconstruction or complex bronchial repairs, or some cardiac even case of some cardiac procedures like percutaneous interventions or TAVI, all that procedural support you can use ECMO, and again that will be for a short time. You have to use less heparin and it has to give rest to the in case of tracheal injury, rest to the trachea, or give some time for the heart for your procedures to get finished. So it can be used as a elective support for elective procedures. Again, in neonate ICU, again the indications are to remain same. They usually go more by oxygen index for a neonatal patients, and in fact neonate has got a better, much better outcome. So it can be used if the OI index is more than 30. You can use it for as a criteria for ECMO. Okay. And more commonly, it is used in case of mecanoaspiration syndrome. It is usually a very short ECMO, usually required in mecanoaspiration syndrome for 24 to 48 hours, and usually they do well. Second commonest indication is PPHN, where it definitely helps. Congenital diaphragmatic hernia, that is the only indication in neonates where the survival rate is around 50% or less than that. The rest of all indications of neonatal ECMO, the survival is more than 70% if it is started on time. Only contraindications for neonatal respiratory ECMO is if they have a risk of IVH is there, or patient has got birth weight is less than 2 kg, then definitely don't consider them for a ECMO. So overall, if you see the survival in neonates, as I told you, is 84% in a respiratory cases, and in case of cardiac, it is around 60%. So survival is much better in neonatal ECMOs, but again, the number are decreasing because of other modalities like HFO and nitric oxide, which is used. Okay. These are the different indications wise in the outcome. As I told you, the only survival is less than around 50% is in case of congenital diaphragmatic hernia. In the rest of the indications, all the survival rate is very good. Especially in mecanoaspiration, the survival rate is almost around 94%. ECMO can be used in the emergency room for an CPR. Okay. So if you are not able to get your CPR is not helping and the patient remains in a cardiac arrest even after 10 minutes of your conventional CPR, ideally the call for the ECMO team should be activated, and this by the time and the ECMO team has to come, and then they should initiate ECMO within 30 minutes after the cardiac arrest. That should be the ideal time. So this is to be limited to a patient which is witnessed cardiac arrest, so either in the ICU or in cath lab or in the emergency room. So where the survival chance is much better and the neurological outcome is also much better. And if you see the data, is almost around more than 10,000 total cases of even CPR has been done all over, with the survival rate is around 30 to 40%. But then these 30 to 40% are the biggest number because almost all of them also were not supposed to survive. And if you go through literature, there are a lot of literature which says that even the neurological outcome in a survived patient is much better. Okay. ECMO in transplant, pre and post transplant ICU, it can be considered. So it can be used for donor as well as for the recipient. For a recipient, it can be used as an ECMO bridge or ECMO support during the procedure or ECMO post transplant. So for a graft dysfunctions, I'll just go fast. It can be used for both lung transplant as well as for the heart transplant. It can be used for the donor also, for a non-heart beating donor to stabilize the patient, or heart beating donor till the time the patient is ECMO, the retrial time comes, you can stabilize the patient on ECMO, and or you can stabilize the organs or preserve the organs on ECMO when in case of donors. So what we call the extracorporeal interval support for organ retrieval. So these patients who are going to be going to be dying, and in fact after that we declare them cardiac death, we put them on ECMO for only for the abdominal organs to be revived. So we put a balloon in the thoracic aorta, so no ECMO blood will go above the thorax, above the abdomen, and abdominal organs can be preserved for the till the time the retrial team comes. So I'll just skip these slides. Or you can just preserve the organs, only just putting up the organs on ECMO. This is known as reverse ECMO or ex vivo lung perfusion. So you only preserve the lungs. Now, usually the life of a lung is only 4 to 6 hours. Otherwise, they develop a cold ischemic time. So if you want to preserve the organs for a long time, you just put the organs on the ECMO and maintain the perfusion of the organs. Okay. So inclusion criteria for respiratory failure, this I already discussed, PF ratio of less than 100 and oxygen index of this. Exclusion criteria is, I discussed with this, and just to summarize. So what is most important is take home message, potentially reversible acute respiratory failure becomes an indication for an ECMO. That's the most important, you should remember. Muir score of more than 3 becomes an indication. PF ratio is less than 100 becomes an indication for ECMO. And if all these criteria, after you try your whatever best protective ventilation strategy, proning the patients, if you want to use an advanced mode of ventilation, you can use that. And after that also, but then importance timing, don't wait for 2-3 days time. It is to be in few hours time, you should take a call. So ideal ECMO candidate is acute disease process, the reversible disease, because then you can reach to them to recovery. And with the predicted mortality without ECMO is going to be more than 80%, you should consider them for ECMO. Most important is at what time you initiate ECMO, because if you initiate ECMO on time, they recover faster, or otherwise that takes longer time to recover. And as the number of days of stay on ECMO and ICU increases, the mortality also increases, because we are worried about the secondary infections and secondary complications. So last, in short, consider ECMO, start thinking about ECMO when the mortality is more than 50%, when the PF ratio is less than 150, start thinking about ECMO, start talking about ECMO, because relatives also take some time to decide, the family will take its own time, you require to organize your teams also. So better to start considering ECMO at when the PF ratio is less than 150, and when it goes to less than 80 or less than 100, you should consider the patient to be taken for ECMO. Similarly, when the inotropic score is more than 20, you should consider ECMO. And the lactase level more than 3 or 4, you should consider patient on ECMO. Or if the inotropic score is more than 40, definitely becomes an indication for ECMO. But most important that I want you to remember is ECMO is a bridge to somewhere. ECMO is bridge to nowhere is not a good idea. Don't make ECMO, just keep ECMO as to prolong the life, but not to prolong the death. That is most important. You should always have where you are going to bridge to. If it is recovery or assist device, if patient is a chronic lung disease and you feel that is not going to bridge to recovery, then there is no point. If the transplant is not possible, don't point in putting the patient on ECMO, because ECMO is not to prolong the days. It is just to prolong life. Thank you. Any questions? I'll be happy to answer.
Thank you, Dr. Oza. You beautifully explained.
I have a question.
Yeah, we have a question.
Please. Thank you very much, Dr. Oza. Very nice presentations. In the question I have an exclusion criteria that you mentioned, that if you have a CPR on witness, and if your CPR take a long time
Your
rather
voice is cracking, Ali. I'm not able to get your voice clearly.
than 30 minutes is exclusion criteria. But we have the same around time. I'm doing the patient on the ECMO. I'm doing the ECMO CPR. Would you mind explain which most are important? If we want to do the ECMO for the patient, 30 minutes is enough for doing, or take the patient out of the criteria.
Ali, your voice is cracking. I didn't get your question.
In the exclusion criteria, you mentioned if your patient is arrested long more than 30 minutes, mentioned that is in exclusion criteria.
See,
But in the ECMO CPR, we mentioned that we have 30 minutes time. Can you hear me? Hello?
can you put your question in chat box?
Hello?
Ali, what I got conclude from you is you are asking about ECPR, and the ECPR usually it has to be done within 30 minutes of the cardiac arrest. The cannulation has to be done for a better neurological outcome. Everything, the outcome depends on how aggressive the CPR has been given and how aggressively patient is managed on CPR. That is what is most important. Usually the call should go within 10 minutes so that the ECMO team comes, prime the circuits, and cannulation process starts.
I mean,
Question on chat box because sometimes the voice are cracking, so we are not able to get the voice.
Okay. So I request everyone to put their questions along while the lecture is going on or after the lecture in the chat
Yeah,
box.
they can put it. We'll either get back to them on chat box, or we can, if the time permits, we'll give them the answers directly.
So can we move ahead with the next lecture? So next will be like Mr. Arvind Sharda. He's a senior perfusionist at Hero DMC Art Institute. He'll be giving the introduction of ECMO. Over to you, Mr. Arvind.
I am Arvind, working in Hero DMC Ludhiana. I am talking about introduction of ECMO. ECMO stands for extracorporeal membrane oxygenator. ECMO is initially a modification of cardiopulmonary bypass circuit, which is routinely used in cardiac surgery. History: in 1953, first case of CPB cardiac surgery done by Dr. John Gibbon, which is successfully cardiac. In 1971, first successfully VV ECMO by Dr. Robert H. Bartley. In 1972, first pediatric case, which is post-cardotomy sport. It is survival. And in 1975, first neonatal case, respiratory sport, which is successfully goal. To keep the patient alive without harming, to improve to tissue perfusion and gases exchange, to prevent multi-organ failure, rest to lung and heart to recover. Principle: the basic principle of ECMO is to pass the blood through oxygenator to allow gas exchange, where deoxygenated blood is drained from patient through the artificial circuit to membrane oxygenator, where the diffusion takes place. Oxygen enriched blood return to the patient with carbon dioxide removal. Why is ECMO used? ECMO is a form of life support for patient like threatening illness or injury that affect the function of heart or lung. It is rescue therapy. It is serve respiratory and cardiac failure respected to conventional treatment. Type of ECMO: Actually, there's two type of ECMO, BB ECMO and VA ECMO. BB ECMO is provided respiratory support only, and VA ECMO provides circulation and as well as respiratory support. VA ECMO, blood is being drained from the venous system and returned to the arterial system. Provides both respiratory, it is provide both respiratory and cardiac support. Achieved by either peripheral or a central coordination like this. This is a BA ECMO. This is a access line and this is a return line. And from access line, it goes to the cone to oxygenator, diffuse here and go to patient's circulation. Actually, we have bridge here for wean off and VA ECMO, providing oxygenation, blood, providing oxygenator blood is being drained from venous system and returned to the venous system. Provides only for respiratory support. Achieved by femoral cannulation to femoral and IJB. Like this. This is the access line. It's from internal. It's from IJB cannula. It's near to postal vein. It's near to portal vein and goes to this negative section to cone. From cone, it goes to oxygenator and deoxygenated and go to return to interjugular vein. There are mostly common used types of ECMO, which is a hybrid ECMO, that is VA ECMO switch to BAB. It's for prolonged VA ECMO can be caused pump lung like North-South syndrome. BB ECMO shifted to BBA. It's failure to maintain hemodynamic or like heart failure, sepsis, shock, sepsis, severe hypertension in RV dysfunction, very highly inotrope sport. So we can shift on to BBA ECMO. This is our components like oxygenator. This is big one is venous cannula, and this is a return cannula. These are the dilators, and this is sheath. We can also customize, or we right now we are using PLS kit. This is our circuit. Thanks. Hello.
Thank you, Mr. Arvind. You can unshare your screen.
Hi.
You can stop sharing the screen. Thank you. Okay, now we'll move on to the next lecture by Mr. Devilal Pandit. He is a chief perfusionist and ECMO coordinator at Medica Super Specialty Hospital, Kolkata. Over to Mr. Devilal.
Sir, I am audible.
Yes, you're audible.
Thank you, all societies that given me the opportunity to speak on this big forum. And thank you to Oja sir. Is visible? Screen is shared, sir.
Yeah, yes, it's visible. It's visible.
So before we starting, Oja sir already introduced his bring a patient. It is ready to initiate the ECMO. So we are the supporting system of the whole system. We are the perfusionist here. Now the patient is ready to initiate ECMO, either VA or VB. uh, previously my speaker already explained what is the circuit. If the patient is required ECMO, we are draining from either any venous system and bringing the blood to the pump, and pump is generating some pressure, and this pressure is finally pressurized blood is finally reaching to the oxygenator. It is in oxygenator, blood is oxygenating, and carbon dioxide is excluded, and temperature is maintained through the oxygenator, and finally going back to the patient either venous system or arterial system. Accordingly, we are telling it is a VA or VV ECMO. So we have a requirement of two types of components. Either it is a machinery, one part is machinery and other few parts is disposable. The machinery around 8 to 10 components is required. As a whole, it's a as a whole system is required, and few disposable systems are required. One by one, I am describing all the things. First, I am describing the hardware component. Now, several types of ECMO machine is available in the market according to our choice. We are either procuring if the machine, several types of machinery. Now, after COVID, in single center, several machine is in the same center, multiple machine in the same center. We are according to our personal choice. We are taking the patient machine to near the patient and introducing, as it's a basic program. We are starting describing a basic machine. It's have some console. I can think of it as the brain of the machine, where we are giving instruction the console, how the machine will run, and some heater unit. All this as a glance the machine is looks like that. So first part is pump. It's the replacement of the heart. It's a work like a heart, where in a hydraulic system, once the water is falling from higher altitude to lower altitude, if we place a turbine where the work is producing, so it's a work producing system. But in pump, where it is work consuming, we are providing some electrical energy to the machine. Machine can rotate, and this through rotation some hydraulic energy is generating. Here the work is being consumed. If we'll go back to the history, in 1852, Alfred Coop, centrifugal casting was invented for manufacturing the steel tire for railway wheels. After in 1852, after 120 years later, biomedicals, this same technology introduced for clinical use. This is the centrifugal pump we are nowadays using regularly. How it's look? The centrifugal pump is the like this type of machine. It's just like a, I hope our audience, most of them, all of having some pump inside in house. So water is getting elevated from ground floor to upper top floor to use in regular purpose. Same pump are using for this generating the blood pressure to the this circuitry. So this pump in center is generating a negative pressure, and it's pulling the blood from the patient body, and as the machine works, it will generate a positive pressure and going out to this path. This is the simple pump and a disposable unit. If we'll think of in details, it's having only 32 ml priming volume. And if we will go back to our physics class 10 or 11, 12 class, it's a working principle of centrifugal force mv square by r. If the mass not having any mass, this machine cannot start working. If not start working,
Hello,
hello,
Devlalji.
yes,
Sorry for interrupting. So your slides are not moving here. Did you started the, I mean, like the PowerPoint presentation? Huh? Just,
yeah,
but the slides are not moving. Actually, it got stuck up.
just a minute.
Dr. Sudhir, one more thing. I think the chat is disabled. We're not able to type any questions. Can you look into it once?
It is share হচ্ছে না কেন?
Okay, I'll just ask the administrator.
Devlalji, try to go into full screen mode and see.
Yes. Now it is visible, sir.
Oh, no, it's still stuck up. Now it's moving. Devlalji.
બધાના સામે બધું જનતે કહેવા લાગી એ સામે ભગવાનના પીર સેટ કર્યો હતો અને આજે આપણે સંતાન પ્રાપ્ત હોય તો તમને સાંભળે છે બધા તે પ્રેમ ફળી આપણે આ વિકલી કલાવતી ઉમર થવા લાગી છે જેથી વિવાહ સંદેશ તતારાનો કન્ડિશન આમ ચાલુ અનેક પ્રકારે દુનિયા શાસન આપી પોતે નગરમાં વ્યાપાર એટલે કલાવતી દેશ દેશની થવા લાગી ચાલુ અનેક પ્રકારની કલાવતી વિવાહ કર્મ પ્રવેશ કરી
Suvirji, there is a lot of disturbance that's happening.
Sir, it is now it is visible, sir.
Yeah, it's, slides are visible. Suvirji, there is a lot of disturbance happening in the background. Did
Yeah,
everyone?
please, somebody's mic is on. I think I
Yeah,
request
please.
everybody to keep the
Let's mute
video on
everyone
mute.
now. Yeah, now it's fine.
Okay, sir.
Devlalji, you can go ahead. Now the slides are moving.
Okay, sir. Thank you, sir. If we go back in our history, in 1852, Alenco, he has manufactured steel cast for railway wheels. The same things in biomedicals. After 120 years later, 1973, this biomedicals disposable pump used for clinical use. Due to the centrifugal pump is looked like that, in center negative pressure is generating and blood is pulling from the patient side, and once the this rotor is vein is start working, due to kinetic energy transferring to the blood, and its hydraulic energy is pushing and generating a pressure to the blood and coming out through the outlet of this pump. If housing is polycarbonate and priming volume is 32 ml, and if we go back to our physics class, it may be in 10, 11, 12 class, it's centrifugal force. The mass, if mass is available, so force is not generating. So initially we
Devlalji,
have to,
sorry. So sorry.
yes,
Again, it's got stuck up. You do one thing, you press on the, I mean, like you click on the slide which you're explaining. You're on 11th slide. It was still the 11th slide is slowing. You're on 12th or 13th slide, right?
right.
Press on the 13th one so that it will get enlarged. Yeah. Do one thing. You instead of going that, you just press on the slide there, which you're mentioning.
sir.
I think then it's getting displayed.
Okay,
Go
sir.
ahead.
Okay, sir. And this is the rotaflow drive unit, and this is the console where we have give the instruction to the machinery. We can think of the brain of this whole system, where we are giving the instruction how much RPM we want to set, and accordingly these two display giving a display of one is for RPM and another for how much flow is generating for the stated RPM. Example, if you set the RPM of 3000 and it generating 3.8 flow, it's approximately 3.8 flow, and because of preload afterload dependent nature of this pump, it is sometime changing. But RPM we have fixed, some 3000 means it is fixed. This is the backside of the machine. This is the power system, and this cable is generating instruction to the rotaflow drive unit. As a whole, this is the disposable pump, and it is a couple with the machine, with the drive unit, and without any contamination. This is connected to the tubing and working nicely. If we'll go to the configuration of this console, it having it's required 220 volt of wattage, like one ceiling fan, current consumption, current maximum 8 ampere, and it's having a battery backup of 1.5 hours. Is whole system is working through the battery, so we cannot remove the battery, start the console. It's a basic information for everybody. It is always working through the battery, and once we start the console, it starts charging. Once charge is over, the display showing battery is full charged. If some power system failure, battery, through battery, it can work for given backup of 90 minutes. But we are not always getting 90 minutes, so we will be prepared for that any other optional system. So this other optional system is hand crank. As most of the center now, the centers are having more than one console in his institute. But previously, every institute having, most of the institute having only one machine. If the patient is dependent on this machine for either respiratory or cardiac issue, interruption of the machine may make a life and death situation. So this industry has generated another backup console. This is the emergency drive unit. Some companies providing two console for one set of machine, and this console we can by hand we can operate, put the pump here, and this through hand we can generate 1.5, 2, or 2.5 or 3 with multiplier of thousand, means 1.5 thousand, 2,000 or 3,000 RPM, whatever it was setted in the console. The next is where we have setted this pump. One wall is generating signal, and other wall receiving the signal. It's a flow, how much blood is flowing through this path it can identify, and some air if passing through this path it can detect and stop the pump. In between we have to put some gel, as this signal cannot pass through air, so we have to remove the air, placing the gel in the gap between the pump and the wall. The next component is oxygenator. This is the another important component, and it's natural lungs having membrane area of 70 meters square, but artificial membrane is 1.8 meters to 1.5 to 4 meters square is available in the market. But if I specifically telling defining this, Mackey oxygenator is mostly using most of the center, as is simplicity and availability. Its membrane surface area is 1.8 meters square. Maximum 12 liter gas flow we can pass. it's having a 3/8 connection. Through this connection, we can generate 0.5 to 7 liter. But in Indian population, most of the patient is in the range of, if it is not obese, is standard patient is 50 to 90 kg. It's require around 4 to 5 liter flow. But where and other few oxygenator is available in the market, we have to choose where, if the blood is passing through the membrane, it's require some resistance through the membrane. It's require some facing some resistance. As the resistance is facing, we are dropping some pressure once passing through the membrane. It is, if according to the literature of this industry, for 4 liter, Macquaid is 33, Chalice is 75, Meadows is 112, and Sorin is 260 millimeter of mercury. So we as instead, I am not biased with the company. As clinically, we should choose the minimum delta pressure available in the circuit for this membrane. Next is blender. It is nothing but a mixing of air and oxygen. We are providing for this oxygenator. Once patient is very sick and supporting for um, supporting is very sick, supporting for a lungs issue, initially is required 100% oxygen, as the membrane surface area is very less than the natural lungs. But once the patient is started improving, we have to reduce the support, and at some time our each and everybody, our audience, we are getting only 21% of oxygen to the system. So patients should be reached same 21% of oxygen till time. We have to support this artificial system, but we have to slowly reduce. Once lungs started improving, we also reduce our support from 100% to 90, 80, 70, 60, 50, 40, and up to 21%. And once it lungs is sufficiently improved, then we reach to 21% and take sufficient time and remove it. For this blender is required. Oxygen air connection. Previously, we are used to use only ventilator for the patient when patient once is sick. So sick, we are not able to manage with the ventilator. Simultaneously, we are using ventilator and Ecmo, and then source of oxygen and air connection is required more in the system. That we have to remember. Most of the ICU used to provide only two oxygen connection, one air connection. So that may we have to think of and introduce in the system. Heater unit. Most of the blood we are passing through this extracorporeal circuit, and the ICU is having the temperature of 20 to 30-degree temperature. Most of the ICU are maintaining it's less than the body temperature. Once throughout the day and more than days, if it is passing through less temperature of the body, these circuits are passing heat through the circuit. So we have to maintain the temperature of the patient. As the clinician is instructed, it should be 35 to 37-degree temperature. So we have to introduce a heater in the circuit. This is the tubing. Nowadays, PVC tubing has improvised. It's having albumin and heparin and albumin coated, so that the activation system should be less reduce the activation, so that we can reduce the use of heparin, and patient should be well. For different reason, sometimes circuit change or any initiation of circuit, we have requirement of clamp and cannula. Definitely, it should be the according to the patient choice, patient's body weight, vascular lumen, uh, different amount of how much blood supply. For all these criteria, calculating and finally finishing how much, which cannula to be used for the patient. One for drainage system, as we are proficient, still we are used to say it is a venous cannula, and other is arterial cannula with the criteria of literature providing from manufacturer. If it is a 3 liter, this pressure drop should be uh, pressure drop should be 20 millimeter for drainage cannula, and for arterial for return cannula it can we maximum we can accept around 50 to 100 millimeter of mercury. Still, another component is required. It is a IV stand with metal base. We can keep these things in between two legs of the patient, and we can transport in hospital for CT, angio, all other things, and also for during transportation. Also, these things we can use this small IV stand with metal base, and require some monitor, small monitor, and simple oxygen cylinder, all these together, and whatever requirement basic things can be kept in a trolley, and one another machine is ready. Both together we can carry to somewhere in either in ICU or anywhere emergency, maybe in other hospital. Do these two things we can carry together and reach to the desired patient place. We can initiate ECMO. If it is not in the city, out of city, all these trolley things can be converted with the whole system, and that should be written one chart box, so that everything, if we'll reach to the desired place, we can initiate ECMO. One day I told our intensivist while we are traveling somewhere, reaching going to retrieve one patient, if these two things together with us, we can initiate ECMO anywhere in the outer field also for within hour, and only our power system is required. So if our friends are starting a IGMO program in their institute, planning a they should plan with the core team, convince the management with ROI, return on investment, procurement the machine. If having a unit with city-based unit, they start the program with long cardiac procedure to use to for the machine, and weekly practice the daily run, and initially they should start VB ECMO and later on VA ECMO. If it is a non-cardiac unit, regularly weekly basis they should practice dry run and start VB ECMO and finally ECMO. This is our perfusionist team from Medica. Thank you.
That's a nice presentation, Devlalji. So explained everything regarding the hardware and how to use it, how to maximize the usage of hardware. Any doubts, guys?
Gangrene and amputation and compartment syndrome. And then dividing all these ECMO runs into various age groups like respiratory ECMO, cardiac ECMO.
Seriously, I think you have to mute something. There's a cross connection that happened. Yeah.
Yeah.
Fine. So any doubts, guys, in this present hardware and then how to run the hardware programs and all these things? Like selection of cannulas and then anything, any doubts you can ask us, or else we'll go to the next session. Yeah.
Okay. Next session is the Dr. Shrishti Jain. She is an associate professor and additional director at the Department of Critical Care at MGMCH Jaipur. I'll be playing a pre-recorded session because she is not able to join live. So I'll just share my screen.
Guys, you can freely type any doubts you got in the chat box also. Okay, if you don't have a time, you are there. Kapil, Dr. Kapil is there, myself is there anytime. So if you just post any doubt, you're going to reply for that. Okay. Let's go ahead, switch.
Hello everyone, I'm Dr. Srishti, and today under the ECMO workshop 1 of the SWAC ELSO 2023 course, we will be discussing how do we prepare the ECMO circuit. This is a little introduction about me. I'm Associate Professor and Additional Director in the Department of Critical Care at Mahatma Gandhi Hospital, Jaipur, and I'm also the Director of the ECMO Center here in the same department. And I was really lucky that during the pandemic of COVID, the first pandemic, I happened to work in UK at the Within Ecmo Center, and could gain a vast experience of managing the ECMO patients. There at one time, we had like 18 patients during the pandemic. So yeah, it was a very overwhelming course of 1 year, but I think it really matters for me today. So you have been studying the following topics so far. You've already studied about the philosophy of ECMO initiation, introduction of the ECMO, and indications and selection criteria, and the components about the ECMO circuit. So now we will be understanding how do we prepare the ECMO circuit. So our core area of discussion will revolve around the priming of the circuit. You will learn this in the practical session also, and as difficult as it would sound, it isn't actually. Our perfusionist team is an expert in priming the circuits of the ECMO using the crystalloid fluid. So priming the circuit is basically filling the entire circuit with fluid, and priming is done by hanging the fluid higher than the circuit and letting the gravity fill the entire circuit. And we prime with the crystalloid solution into discussions further. And de-airing is again a very important part of the priming of the circuit, and it basically means removing all the air bubbles from the circuit. The references which I have given below are great sources to read further. So the circuit is basically a Formula One racer track, right? The Alfred ICU Group of Australia, they very nicely described that. Don't get a lot confused with the circuit. It says basically this is the North Carolina track of the Formula One race, and this looks complicated. And the whole fluid running is like, you have cars running on the track, and that's it really. It's not that complicated as we think. So component of the ECMO circuit, you need the machine, right? You need the console, which actually acts like a centrifugal pump. You need the oxygen supply and need a water bath to control the temperature. Another circuit, we have the tubing, a membrane oxygenator, a pump head or the cone, which we call. And these all components are called as disposable components because they are coming in contact with the blood, and we basically discard them after they have been used. And the ECMO trolley, which is the support structure that holds all the equipments. So this is our centrifugal pump or the console, and this is the circuit. Oxygenator is part of the circuit. And this is the whole trolley after you see once everything has been configured. So this is the console, this is the heater unit, and this you can see is the oxygen cylinder. This is the rotaflow drive unit on which you will attach the cone. And we have an emergency drive, which is the hand crank, which we use when in case of circuit failure or the machine failure, right? So this is how the whole coordination would look like. Um, some of you might be using CentriMag. I've used CentriMag when I was working in UK, and this is how it looks. It has a display monitor. It has a blender or a sweep gas. The pump console looks like this. It's very small, and this is the centrifugal pump and the oxygenator here, and the heat exchanger is here, right? And the arterial venous circuits is here. So this is how your configuration would look like, right? So when we are priming the circuit, we are basically establishing a connection. This yellow is the track, the connection between the circuits, right? We use Hartmann solution to prime. We have a reservoir bag which helps in removing the extra air and the fluid. And this is how the circuit would look like once the priming is done. And when you connect it to the patient, so this part would be disconnected, and from the patient it would be connected like this, and to the patient it would be connected like this. So this is actually what we are going to learn in the coming session. And to understand more in detail, so this is how the circuit would look like. So from the venous cannula, you take out the blood from the patient, right? The pump rotates at a very large speed and creates a centrifugal force, which gets the blood from the body, and then the blood goes into the oxygenator, where the circuit gets oxygenated blood. Basically, it gets oxygenated, and the CO2 is also removed, and then this blood is returned back to the body. So understanding the technical data about the PLS system, so the total priming volume needed is around 585 ml. The blood flow rate is 0.5 to 7 liters per minute, and the gas exchange surface area of this oxygenator is around 1.8 meters squares. The heat exchange surface area is around 0.4 meters squares, and this is the water connector, the housing material, the fiber material for the gas exchange, and the fiber material for the water flow. And the centrifugal pump has a surface of around 190 centimeters square. It is made up of polycarbonate. And understanding the rotor flow console, the maximum speed that you can achieve is 5000 RPM, and the resolution of the display is 0.01 liters per minute. The flow rates are 0 to 9.9 liters per minute, and these are the dimensions, and weight is approximately 15 kgs. So this is how the technical data would look like. So priming the PLS ECMO circuit. So priming must only be performed by the clinicians who are trained and experienced in ECMO and who understand the potential consequences of an error during the priming. The principle of priming the circuit is to maintain cleanliness and to minimize the possibility of air emboli. The priming procedure is a sterile one, meticulous, step-by-step procedure that involves at least two people, one sterile primer and one non-sterile helper. The equipment required for the procedure should be fetched from the ECMO storage area and taken into an empty wet space. All right. So these are the components of the PLS circuit priming which are needed. So we need the ECMO PLS console, we need the PLS circuit, we need a carbon dioxide cylinder and a large trolley. And consumables that we need is a sterile gown, gloves, mask, hat, 5 3-way taps and extension, 2000 ml of saline bags, 2 sterile drapes which are fenestrated, cable ties and cable guns, and Lowell's bag, they are also known as the reservoir bag, and 20 mils syringes. So when we start priming the circuit, these are the actions which the perfusionist would take for the priming of the circuit. These are the guidelines which are taken from the NHS Trust within Shaw, where I used to work, and I'm really thankful for them to share this with me. So first of all, we have to get the height and weight of the patient to ensure the correct cannula selection. If the patient is more than 120 kgs, we have to consider using a second oxygenator. Check the expiry date and the package integrity of the oxygenator, and open and place it in the holder of the ECMO pump, and tighten the connections. Keep a lot number for the records, right? So this helps in determining the appropriate circuit selection prior to priming and insertion. Pressure test the heat exchanger to ensure the heat exchanger integrity. Check the expiry date and the package integrity of pump, and open and place in the pump head. Keep lot numbers for record. Check expiry date and package integrity of the priming bag. So all the components you are using, please check the expiry date and the packaging integrity. And then for this, you will hang the priming set and reservoir bag on the ECMO trolley drip stand. Then you attach the pigtails to the oxygenator heat exchanger lever, oxygenator outer lever, and a 3-way tap to the lowered pigtail on the top of the oxygenator. So these connections are very important that you have to make before you start priming the circuit, because they help in measuring the pre and the post membrane pressures, and they come with the PLS kit itself. Then you hang 1 liter of Hartmann's solution on the ECMO trolley drip stand. You fully close the white clamp on the prime line to the priming circuit reservoir bag and attach the Hartmann solution. Then you clamp the inlet and the outlet lines appropriately 2 centimeters from the reservoir bag, and then you clamp the blue and the red ends of the priming circuit. You fill the reservoir bag with the Hartmann solution, ensuring that the bag is full, and a fresh bag of Hartmann's replacing the empty one. Tilt the lines upwards and release the clamp on the drainage line adjacent to the priming bag, and then using the clamp at the end of the drainage line to control the flow. Then you prime the drainage line, that is the blue line, ensuring an air-free prime. When complete, you reclamp the drainage line. So all this is done to prime the circuit in an air-free manner. So this is the figure 1, and we can see that they are connecting the circuit to the pump head, and it is the only tube which must be connected, and it can be sometimes really hard to connect this tube, so we have to be really sure that it is connected properly, right? And once it is connected, you save the tube to the pump head. Then you connect the tubes from the saline bags. This is how you connect the tube from the saline bags, and then you clamp the line between the 2 3-way cocks, right? So these are the 2 3-way cocks, and in between them you clamp the line. Then you help with the help of the gravity, you fill the pump, right? And then you apply the ultrasonic gel to the flow head on both the sides of the flow head, and then you open to the atmosphere so that the de-airing is done, and then you active priming of the tubing set with the rotor flow pump. We will understand all this in detail by seeing the video also, right? And then you close the three-way cork to let the priming solution flow inside the bag, right? You open all the clamps to de-air the system. Then you prime the lines, and the priming lines can be removed. You clamp the lines, and then the set is ready for sterile application. So understanding this in step-by-step manner, you open the pump head and check for signs of the damage before priming. You attach the tubing bridge to the pump outlet, clamp the pump outlet tubing. This is done to ensure pump equality and the preparation for the priming. Then you attach the prime drainage line from the priming set to the pump inlet and tilt the pump and outlet upwards. Remove the clamp from the pump inlet and using the clamp on the outlet, ensure an air-free prime of both the pump and the outlet tubing. Reclamping of the end of the outer tubing when complete. Then you make the connections to the oxygenator blood inlet with the pump outlet tubing and you attach the return tubing red from the priming set to the oxygenator outlet and leave clamped. Open the pigtail onto the top of the oxygenator. You then gently release the clamp on the pump outlet and slowly prime the heat exchanger up to the pigtail at the top of the oxygenator. You close off the pigtail when fluid is detected and use the P1 pigtail to remove any air present with the heat exchanger. So P1 pigtail is the one which is pre-pump and that is used to measure the pressures. Now gently release the clamp on the oxygenator outlet and control the priming of the oxygenator, ensuring an air-free prime. You ensure all pigtails are purged and the caps on the oxygenator are also purged, right? So this is done to control the priming of the oxygenator in an air-free manner. You place the CentriMac pump in the console. Since they were using the CentriMac pump, it can be any pump. So you place the pump in the console, attach the flow probe to the oxygenator outlet tubing and remove all the clamps from the circuit. Start the pump, de-air the circuit and increase the flow up to 6 liters per minute. You manipulate any air and use 50 ml syringe on the top pigtail to remove air bubbles. Ensure the circuit is air-free. Reclamp oxygenator outlet ready for insertion and turn off the CentriMac pump or the Rotaflow pump. This is to ensure the de-airing of the oxygenator and prepare for the storage or transport of the Ecmo circuit. Then you clamp both the tubes between the reservoir bag and sterile priming tray. Carefully remove the gas tape securing the lid. Remove the lid and allow the sterile tubing to be removed by a person in the sterile field. Ensure that the reservoir bag is held securely during this procedure. This is to ensure the sterility and prepare the Ecmo lines for separating from the priming bag. Then the sterile tubing should be cut in the sterile zone, distal to the tubing clamps beneath the reservoir bag, and the reservoir bag can be discarded. So this is to ensure sterility of the tubing connections and disposal of the priming bag. So this is all we are doing when we are ready for the primed circuit to be used for connecting to the patient. And you ensure a loading dose of heparin, 75 units per kg, international units per kg, to the patient after the first guide wire is inserted during the cannulation, and you confirm the adequate anticoagulation via ACT prior to the commencement. To ensure adequate anticoagulation to prevent a thrombosis, this is how you do this, right? An air-free connection to the cannula is made by using a syringe of saline during the tubing connection. You set the blender or oxygenator flow rate to the desired level. If using sachets, ensure 100% FiO2. Ensure circuit is clamped post pump outlet. This is done to secure priming of the circuit and to give perfusionist control of initiation of Ecmo. And then you start the CentriMac pump with clamps still on the oxygenator outlet at the 2000 revs per minute. When ready to commence Ecmo, slowly release the clamp and increase the RPM to achieve the desired flow. This is done to make sure that there is no backflow in the circuit, right? So this is one PLS priming video, which I think we all should watch together so that our concepts are clear. And this video has been made by the Alfred Medical. So I hope the video made a little bit easier for you guys to understand that how we prime the circuit. And more or less, it is the thing which is done by the gravity method. Any one of you all who would be working in a cardiothoracic OT, since most of you all are from the perfusionist background, some of you all from the nursing background, but I'm very sure that on the practice sessions, things will be made more clearer. Just remember gravity. That is what is helping you to fill the water into the circuit, and you don't want any air into the circuit. I know that where are the ports where de-airing can be done. All right, any air which is there prior to the oxygenator, you don't need to worry about. The oxygenator will itself help you to de-air the circuit, de-air the air. But any air which is after the oxygenator, that is something to be worried. And we have to be very, very sure that all the air has been removed from the circuit. So after we have primed the circuit, we can do this kind of paperwork where we prepare a kind of a sticker to be stuck on the console that the ECMO circuit was prepared by so and so on this time and this date, assisted by this, and this circuit can be used for the next 28 days. So centers which are high volume centers always keep a circuit primed. Rather, they keep two circuit primed. For example, if there is an ECPR emergency, they can take the primed circuit, or if they are having any kind of emergency on the patient who is running on ECMO already. So ECMO cannulation checklist. So after the priming of the circuit, we need to go forward for the cannulation. And this is a very nice ECMO cannulation checklist prepared by the Manchester University group. And so in this checklist, they tick box the things which have been done. So a referral form has been obtained or not, yes or no. On-call ECMO consultant informed, yes or no. Mobile ECMO, yes or no. On-call perfusionist contacted. Ambulance arranged, following the oxygen cylinder is used. Oxylog tubing attached and etc. Like they use this transport ventilator, they call it Oxylog. Whatever transport ventilator you are using in your center, pressure bag, transducer set, flush bag, transfer check bag has been checked, cannulation box has been checked, sterile ECMO pack has been checked. TOE machine, they always take it on transportations for the cannulations to confirm the position of the ECMO cannula, and they ensure that what is the time of contact and the time ambulance ordered, and they keep the labels everywhere so that things are not get confused between two users. We check for the ECMO drugs, whether they are in the fridge or not, blood groups, cross matched, how many units as the referral team has in their hospital. X-rays and notes have been copied, patient address and GP details. In NHS, they want the GP details as well. Relatives or consent, referral pack checked, mobile MDT has been done or not, contact switchboard, and this is how they have to check everything. So, heparin or vancomycin prepared or not, whether the platelets or albumin is needed, referral form has to be attached, transfer sheet, consent, all this has to be attached to the file of the patient. And this is the cannulation record of the MFT. So they record the patient's name, the NHS number, the date of birth, height and weight, and what is the pump, what is the lot, expiry, type of ECMO, what apparent amount of bolus will be given, and circuit connections, right? So perfusionist and the consultant. So the cannula, what are the cannula, who is the manufacturer, what is the position of the cannula, name of the perfusionist, consultant, cannulating consultant, ECMO coordinator, what is the type of the oxygenator, what is the priming solution, ACT, time on ECMO. So all this is being recorded along with for the cannula, they also record the position, size, lot number, and expiry, and the parameters at the initiation of the ECMO. So, what is the flow cap, what is the RPM, what is the sweep gas, FiO2, oxygenator P1, P2, and the gradient of the pressures. And for the handover, they do this, follow this checklist where the oxygen or air is connected to the hospital supply, card connected to the main supply, oxygen line connected to the oxygenator and blender, heat exchanger connected, temperature set and checked, flow and the pressure alarm set, and the full emergency oxygen cylinder is there on the card. So all these checks are made. So I prepared my presentation using the resources from the Alfred Health. They have very good resource for the ECMO. There all the guidelines and procedures are really practically applicable. So please go through this. I have given the link here. So Alfred ECMO guidelines. So this is a clickable link, and I will share the link of the presentation with you boys. So you can see the Alfred ECMO guidelines and also the NHS Trust services. They are available on their intranet. If any one of them wants to access, they can freely ask me. So, and this is a more of a theoretical topic right now, it seemed, but I'm very sure that when you come on the basic track, you will definitely win this Grand Prix. So it is nothing but writing the cards, through the circuit. So thank you so much for your patient listening. I would end the presentation here.
So this was a pre-recorded uh, lecture by Dr. Shrishti Jain. So any comments or questions? Okay, I guess we can move over to the next lecture. Next one is by Dr. Krishna Gula. He is intensivist division of pediatric pulmonology and intensive care at AIMS Bhubaneswar, Odisha. Dr. Krishna will be speaking on relatives preparation and team preparation and allocating work. Over to you, Dr. Krishna.
Yeah, thank you, Dr. Suvik. Is my screen visible?
Yeah, it is visible now.
My slides are moving now.
They're moving.
Yeah, thank you. Thank you very much. So my topic for next 15 minutes is how to prepare the family and prepare yourself when you are starting an ECMO. So what I say is that whenever you take a patient at ICU or cath lab or OT, we should have some idea that this patient may need ECMO. For example, if we're taking a patient, because I'm a pediatric pulmonology intensive care specialist, I will be talking more in relation to the pediatric population. So, for example, if we're taking a case of TZA, you're operating at 6 months of the years, where the by the way, LV is regressed. So you expect that this patient may not come out of bypass and he may need ECMO. So this type of pre-notion that this patient may need ECMO that you need to have in your mind. And then in the ICU or in a cath lab or OT, so once you have taken the decision that ECMO needs to happen in this patient, so first you need to prepare the site where I wanted to do ECMO for this patient. Do I want to do ECMO in the ICU itself or in OT itself and bring the patient back to the ICU for the post-operative care also? And second point is, and when you took the decision of ECMO, you need to prepare your team as early as possible. And before first you get convinced that I am going to start a ECMO for this patient, and then you start the family prepared for ECMO. So whenever you're talking about the family preparation, the first foremost important thing is identify the person in that family who takes decision. Usually in our scenario, in an Indian scenario, either it is father or grandfather. So usually mothers or female relatives are usually not a decision makers. That we need to identify that particular person and talk to them first. And also the primary physician who admitted the patient into your ICU, or you referred that patient to for a surgery or so, and he plays a very important role in preparing the family when you are thinking of ECMO. And always talk to the parents or family in a simple language. And it is better to avoid the medical jargon, what we commonly use in our ICU. For example, if the patient is on ARDS, and you tell them that, don't tell them that his oxygen index is more than 25 and PF ratio less than 80, that's why putting an ECMO. It may not, family may not understand what you're telling. So just tell them that the patient is having the patient is having bad lungs. And the things which you are doing with ventilation we are not able to maintain this oxygenation, or we are not able to remove the carbon dioxide. That is the reason we want to go for escalate the therapy from ventilator to ECMO. That much we need to tell them in a simple language. And you need to convince them regarding the need. Why do you want to do the ECMO? And it is better to tell your success stories of ECMO in last few months, telling that this patient had cardiac problem, we put an ECMO and he survived, and this patient had lung problem and they required ECMO and survived. So it is better to give some success stories from your experience. And at the same time, we need to tell them that the ECMO is not a very big magic thing that cures the patient, and it is only supportive till the lung or the heart recovers its function. and tell them that from the beginning that it is not curative, it is only supportive and gives time for the child's or the patient's lungs and heart to recover. And you need to think the family perspective. We need to put our legs in their shoes and then prepare yourself. And it is what I say is that you anticipate what a family member will ask when you are talking about ECMO to them. So just tell them that why their loved ones need ECMO, what is the need, whether it is cardiac dysfunction or it is lung dysfunction or both. And just tell them that how the ECMO works. Just it is better to give them a pictorial representation. As previous speakers, they had shown what is the from where the blood is drawn from and from where it is taken by the it is sucked by the a pump and given to the oxygenator and then given back to the patient. So it is better to give them in a pictorial representation and tell them that the pump in the circuit acts as the heart and the oxygenator acts as the lungs. The circuit acts as vessels, blood vessels. So it is, if you tell them in a simple way, they will come to understand. And also, you would need to tell them that how we are going to put their loved ones on ECMO, whether it is by doing sternotomy or by doing peripheral cannulation or by doing semi-selling technique, that we need to tell them in a simple language. And again, in our scenario, the finances is the most important part that plays a role. And what I suggest is that whenever you preparing a family for ECMO, don't start with the finances first. First, start with the what is the need of the patient, why you are planning for ECMO, and tell about the outcomes. If you are pretty confident that this patient may come out, and then talk about the finances. And same time, you tell them that ECMO is not you need to tell that it is a cost of entire ICU care rather than ECMO itself. Sometimes because if you tell that ECMO costs around 5 lakhs, 10 lakhs, and we all know that it is only about a circuit, there are other things that is antibiotic for infection, infusion pumps, infusions, vasopressors, ventilation. So the n number of things that adds to the cost of the patient when the patient is in ICU. So don't press upon only the ECMO and tell them that the cost is for the entire ICU care. And they may ask simple questions. As I told you earlier, you need to be in their shoes. So they will ask whether this will painful to my baby or my patient or my brother or so, whoever it may be. They tell them that yes, there may be some pain, but we are giving medication to reduce that pain. And they will ask you, will they be, once the patient is put on ECMO, they will be able to come and see the patient or child? Yes. You need to tell them that yes, you can come one by one and see, and with all aseptic measures, you can come and visit them in a particular time. And they will simple ask, will be able to feed the patient, they feed the child. And tell them, yes, we can feed once the hemodynamics, once the heart function becomes normal, becomes okay. And they may ask you who are all going to take care of their patient. They need to tell them it is a team, dedicated team for ECMO is there, intensivist, ECMO specialists, nurses, physiotherapists. There are n number of our team will be working on your child or patient. So don't worry that we will be taking care of the best effort that we can do. And other important question they may ask you is how long the patient will be in ECMO therapy. So our advice is that it may not be. It is a very tough question to answer for any intensivist or ECMO specialist. Tell them that for roughly you tell them that it may not be possible at this point of time to predict how many days it will go, but you can tell them that on an average a VA ECMO takes around 10 to 14 days. And a VV ECMO takes around 2 to 3 weeks. But it's a rough number, but don't commit that this is at the point where you're going to remove from the ECMO. And again, after telling the need of the patient, need of ECMO for this particular patient, and why we are doing the components and cost, after that, and we need to tell them about the complications as well. So, and don't shy away with complications by explaining to them, or give, and same time we should not be give too much importance to the complications, pressing on the complications. To extent that they will become afraid and they will not consider for initiation of it. And you tell them the cannula complications like well, sometimes vessel injury may do when we're doing cannulation, and they may be bleeding, or at times you may not be able to secure the cannula also at times. That you need to tell them. And the most important is bleeding. You tell them that we will be giving anticoagulants. That means to thin the blood, we give anticoagulation, and with that there are chances of bleeding, and then the child, the patient may require high amount of blood transfusion products like PRBC, platelet, FFP, cryo, etc. And if the bleeding is so much that he may need some surgical interventions to stop that bleeding. And at times, if there is a massive bleeding like intracranial bleed, we need to take a call for stoppage of ECMO as well. And same time, we need to tell them about the clotting, especially in case of VA ECMOs, and stroke in case of VA ECMOs, and infections are very important in our setup, with which we fight day in and day out, not only for ECMO patients, for non-ECMO patients as well. And ask them to arrange donors, blood donors. So keep them prepared. You tell them that it is blood products are not are drugs that are not manufactured in the company. One has to donate these products so that we can give the blood pressure to their patients uninterruptedly. And again, once you tell about these indications and complications associated with the procedure, and you need to take, in a simple language, you need to take the consent with all the mentioned about content which I told you earlier, that there should be written informed consent, and it is better to have video recording of the informed consent for future references in case any any problem in the future. And if your hospital policy agrees, then we can advise for crowdfunding if the finances is an issue. And we need to tell them about not only putting on ECMO and duration, the estimated duration, that rough duration, and then we need to tell them the decannulation related issues as well. So it is all like when you go for air travel, so the taking off as well as landing, both are important. And we know that the majority of these accidents are being occur during the takeoff or landing. So tell them that the putting a patient on ECMO as well as weaning and decannulation also both are equally important. And don't you tell them that unless the patient is decannulated and stable, and don't give them very positive positive response to them. That may be because once we do a number of these things, we will come to know about this. This is about the consent which we use here, and this is about family preparation. So once your family is okay that yes, you go ahead for ECMO, and then you need to have our own ECMO team. If it is a high volume center, already dedicated ECMO teams are there. So they can, once you give the bell of starting ECMO, the entire team will be ready. But majority of centers, where is the low volume center, there you need to make your team at that point of time and then allot the duties to a particular person. And again, we know that this well-coordinated manpower is much more costlier than any equipment in the world. That is what others I wanted to highlight upon. And while you are making a ECMO team, so take the primary physician who admits the patient into the confidence, into the team, so that he will help you a lot. You make him as a part of your ECMO team, so that he will be talking to the parents and patients. So the patients usually have more faith on the admitting physician, because ECMO team is the one that usually enters into the picture when the patient is very sick. So they may not be more may not have more confidence on a person that see later in the course of the illness. So it is better to have the primary physician on the board from the beginning and keep your Ecmo team informed. And since beginning, make a roster to avoid burnout. That is much more important. And share the responsibilities and motivate your team by memorizing your previous success stories and Ecmo. This is much more important. So when you initiate the Ecmo, so you should have an Ecmo physician specialist who can be a intensivist or pulmonologist or pediatrician, pediatric intensivist or perfusionist or cardiologist who have been trained and took training in Ecmo. He can be a team leader, and you should have intensivists on the clock, residents or Ecmo fellows on the clock, and the cannulation specialist. So it all depends upon where you're doing the cannulation. If you're doing central cannulation, the CT surgeon is the one who does the cannulation. And if you're planning for peripheral cannulation, it can be done by intensivist or vascular surgeon or CT surgeon, depending upon availability in your particular hospital. But you should have a perfusionist on the clock. It is possible, avoid on-call perfusionists because majority of the hospitals may not have the full-time perfusionist. It is better to avoid it. Part-time perfusionists, and critical care nurse who is already exposure to the Ecmo around the clock, the transfusion and blood bank, and you should have a social worker since beginning and a chaplain so as to motivate the family religiously. So once you have Ecmo, you should have the physiotherapist with you, microbiologist for quick reports of culture reports, infection control team, radiologists, and ENT surgeons in case you need a tracheostomy. So it is once you start, you need to have the support of all these members. So physicians, perfusionists. Becomes a bit better. Am I audible? I think it was.
Yes, you're audible, but your screen sharing has stopped. Just restart it.
Okay. I think this slide was okay, no?
Yeah, this is okay.
So at the center of the patient, and so many of us are working on the single patient to make him survive and to take him out of Ecmo. So, and again, other is your hospital administration should be a part of your team. So unless their support is there, it is difficult for us to maintain the Ecmo for a long time, the program for a long time. So what so at last I want to say is that Ecmo is a teamwork. It is not a single man army. The patient is our priority, and treat family also as a part of your Ecmo team, and avoid burning out so that you can do a number of high volume Ecmos in our institution. And it is all about the teamwork that I was telling from the beginning itself. Thank you very much for this opportunity. If you have any questions, I'd be happy to take them.
Thank you very much, Dr. Krishna, for nicely explaining the important aspect of relative preparation and team preparation. Any questions? All right, I think we can move ahead to the next session. It's by Dr. Rakesh. Dr. Rakesh, he is heading the critical care and Ecmo unit at JMK Hospitals, Hyderabad. And he'll be talking about pre-Ecmo patient preparation, pre-initiation checklist. So you can start. Moving over to you, Dr. Rakesh.
Thank you, Shivaji. Am I audible?
Yes, yes, you are audible.
Yes, fine. That was a nice presentation by Dr. Krishna regarding preparation of relatives. So every point what he mentioned is actually practically very good point he has mentioned. So myself, Dr. Rakesh. Second, is my screen is shared?
Yes, it is. We can see the screen.
Yeah. So myself, Dr. Rakesh from Jabja Hospital, Hyderabad. So in the next few minutes of my topic, I'm going to talk regarding pre-ECMO patient preparation. So how you are going to prepare a patient now. Once you're done preparing your relatives, so your consent is in your hand and everything is done. And then you need to have a checklist for your ECMO preparation. Like once you are going for cannulation, you need to have a checklist for the patient also. So let's see what things you need to keep ready. So once you're ready for your cannulations part. Okay. So preparation is actually important in every single step, whether it's going to be an exam or it's going to be a cannulation or it's going to be anything like a journey. Simple journey also requires a preparation to have a facility experience here. So once you're prepared for all the complications, once you're prepared for all the outcomes, once you're prepared for getting a better results, so your preparation will show the how beautifully or how smoothly the ECMO initiation was done and followed by weaning was done. So you need to have a strong preparation. So even in ECMO also. So you need to counsel the attenders. I think my previous speaker has covered it adequately. Then now the point comes is you need to have a preparation for the patient. So most of the times our ECMO patients will be not conscious. They are not conscious enough to give the consents and all. So the most of the times they will be under ventilatory support with sedated and paralyzed things and all. Very less likely you do have an awake ECMO patients. Okay, once you have an awake ECMO patients, you have to explain the procedure. Same as like for any small procedures, you have to take the patient consent from the patient also. You need to keep the machine and the circuit study. So I think the machine and circuit will be dealt in detail in the next coming sessions and all. So attendance, yes, you need to counsel regarding them for the consent, the treatment, the duration, chances of transplant, the life of the circuits, everything should be counseled to the patient attenders. So, but at the same time, they should not get a more knowledge than you. So you need to be counseling them, or like the previous speaker is telling, you need not counsel them regarding all the complications because if you throw light more on the complications, they'll just back up on the ECMO treatment itself. Okay, and then preparing the patients for the for the complications like sepsis. So whenever there's a chance, so don't just go on and candidate just thinking of it's a VV ECMO. You should be always prepared to convert it into VA ECMO also, especially it's going to be an outstation initiation and also bleeding. And then finally, financially also, the information has to be gone to the patients. So let's see when it comes to specifically on the patient. So what should be your cannulation site? So it's always preferably on the right side because the right jugular and right femorals will have a straighter course of action compared to your left sides. So you'll have less bends, less chance of kings, and less chance of having hematomas and all. So preferably on the right side. So what if you have a right side center line already for this patient? So just shift that center line to the left side. So place the center line always on the left side. There are some centers which initiate ECMO without a center line also, which I strongly suggest no for this because you need to have a center line whenever you're going for initiating for ECMO for any type of patient. You need to have a center line that should be preferably on the left side. And by keeping center line on the left side, it does not mean that you're completely safe. So in all the three ports of the center line, you should always keep one port free, and that should have an extension of 100 centimeters connected to a syringe with a three-way, which should have always a flush, then the drugs loaded and all. Because once you're ready for the ECMO, you'll cover the patient completely, which I show the picture of the patient in the coming slides. So once you cover the patient completely, we don't know where the drugs to give. So there are multiple instances where you think that the drug is being given and the drug will not go into the patient, which happen in terms of cardiopulmonary bypass. So you don't want to go into those complications. You always keep one port free for giving drugs during your initiation part, and that one port should have a 100 centimeter extension line, and that one should be handled by a separate person. So why there should be a sheath or an arterial wagon on the left femoral? So it's just what is a it's a protective measure. So in case if there is a cardiac arrest or a cardiac tamponade that happens, we always like my center always advocates to have an arterial line on the left side so that in case of a cardiac arrest, once the cardiac what is a CPR is going on, they can always convert from VV to a VA ECMO. So that's the advantage of having it. And at the same time, you can also use it for monitoring the arterial line pressures also. And then don't forget to increase your ventilator settings before going on for ECMO. And then once done with all your basic preparations and keeping a central line and everything, you need to do the basic biochemical profile for all the patients. You need to do a CBP. So by doing CBP, yeah, your hemoglobin target should be more than 10. You need to do a renal function test so that your electrolyte should be within normal limits, because you are almost diluting the patient's blood with 700 to 800 ml of your plasmolite with the newly primed Ecmo circuit. And then the coagulation profile, you need to have a basic coagulation profile just like any other procedure inside the ICU, and do a routine virology, and then comes the albumin also, because you're diluting again, your albumin also will get low in these patients, and then basic ABG of the patient. So why ABG is required before going for ECMO cannulation? You need to know what are his basic CO2 levels. There is no problem with the oxygenation per se, but if the CO2 levels are too high before cannulating, so you need to make sure that the level of carbon dioxide decrease should be very gradual. It should not be abrupt within a span of 10 minutes or 15 minutes. Don't target a normalcy in your carbon dioxide levels. That causes a lot of cerebral flow disturbances that might lead to your CVA, strokes, and all those things. So check a baseline APG so that it will give you a baseline measure how fastly you are correcting the CO2. Okay. So let's see the targets before cannulating and how best you can optimize any patient, as I said earlier. So apart from routine things, physical things, hemoglobin should be more than 10 grams. Your coagulation profile, INR, PT, and APTT, along with that, platelets should be more than 1.5 lakhs. Your renal function test should be within the normal limits. Albumin target should be always more than 2.5. And then your electrolytes like calcium, magnesium, phosphorus should be normalized, and ABG just to know how fast you are correcting these things, and echo. So before going for cannulation, try to do echo for every patient. There is always some sort of left ventricular, what do you say, dysfunctionings that might happen, that might, or there will be severe PAH that will guide you. Okay, that will guide you to go into which type of echo. Say, for example, if there is a ARDS patient, severe ARDS patient, and then in a septic shock, if this patient does not have any left ventricular dysfunction, you can go for a plain BV ECMO. That's only because of oxygenation. Patient is having hypotension and the sepsis. If the same patient is having a severe LV dysfunction with an ejection fraction of hardly around 20 or 25, so your thought process of placing a VV ECMO is again questionable. You might try a VA ECMO in these situations also. So echo, you need to do an echo also prior to going for a decision of which type of ECMO to be initiated. So as I'm quoting earlier, you need to have all the drugs loaded. So don't think these guys are getting wasted. You need to keep the drug loaded and kept ready, because time is life here. So you need to have an adrenaline 1 is to 10,000 and adrenaline 1 is to 1 lakh dilutions kept ready in syringes. You need to have an atropine loaded and kept ready. Sometimes these patients will have severe respiratory acidosis that might be causing severe hypotension in these patients. You need to have soda bicarb kept ready, calcium gluconate. Yes, these patients will have severe hypocalcemias. And then with the VV ECMO initiation, they might go into severe hypocalcemia again, especially in case of neonates and especially in case of pediatrics, because there you are double diluting the patient's plasma volume, sorry, the blood volume of the patient. Yeah, apart from all these things, you need to sedate and paralyze the patient completely if it is going to be in a severe disease. If it is going to be a mild, moderate disease and they're planning for an airway ECMO, try not to sedate and not to paralyze these patients. So these drugs should be kept loaded, and then along with a flush syringe of 50 cc, they should be kept and connected to your three-way port, which I'm mentioning earlier. Other than those things, the most important drug being your heparin. Okay, so the heparin concentration and heparin drug should be always be kept loaded and then given to the patient before going on for cannulation. Along with the heparin, you need to have 50 cc syringes in line so that we'll go for ECMO cannulation very smooth. So now let's see. So once you are done with the patient, what do you say, optimizing the patient hemodynamics, optimizing the patient's biochemical values, optimizing the patient. Let's see how many machines you require here. So one is your basic ventilator, which is already there for this patient. Yes, you need to have an ECMO machine done, kept ready on the bedside of the patient, and you need to have an ultrasound machine with all the three probes. You need to have an echo probe, to have a vascular probe. So, vascular probe, why you require a vascular probe in this situation is to measure the diameter of the vessel. Measure the diameter of the vessel and then convert it into French factor. So once you convert it from mm to French, you know which type of, which size of cannula to be placed. Okay, and then along with that, once the guide wire is inside, you need to have a cardiac probe so that the guide wire should not go inside the. Until you're going to cannulate this patient, you need to monitor the echo of the patient, because we don't know whether the guide wire goes and ruptures your right atrium, causing your cardiac tamponade. So all the three machines, yes, One more important machine being your ACT machine should be kept ready on your bedside, because once the patient is heparinized, once the guide wire is in, we'll try to heparinize the patient. And once you heparinize, the ACT should be measured. So that should be kept ready. Along with that, a multi-parameter monitor for the patient and one monitor for your circuit also. If you are measuring your pre-pump and then your pre and post oxygenator, P2 and P3 pressures. So because MACA does not have an inbuilt P2 and P3 monitoring systems, you need to have an extra monitor for that. So these are the machines. Apart from the machines, let's see what stuff you require. One is your ampliance guide wires, and then you need to have dilator sets of all sizes. Along with that, you need to have at least 6 clamps on the patient bedside. So just remember only one number in ECMO, whether you're cannulating or whether you're decannulating or changing any part of the circuit, you need to have at least 6 clamps. So always, if a patient is there in your ICU, 6 clamps should be there on the patient's bedside, and then one hardworking scissors. Okay, these things should be kept ready. Once these things are run, next thing is selecting the cannula. So if it is an arterial or a venous cannula, you should select the cannula size, or 20 or 22 size of the cannula. Based upon the availability of different companies, there are different sizes of cannulas, so which we deal it in coming sessions. So you need to select the arterial cannulas, and then you need to select the venous cannula also. So you need to have a venous cannula that should be selected and kept ready based upon the size of the vessel, the flow requirements, and the duration which you are expecting also. So once the cannula is kept ready, you need to have one smaller size cannula than the preferred size. Say for example, by measuring, you just came to know that the 25 size cannula is the maximum one that goes into the vein. So you need to have a 24 or a 23 cannula also kept ready on the bedside. So that's the idea here. Keep 2 cannulas, one size lesser. Just like you're going for intubation, you keep all the size of tubes. Okay, the same thing should happen even in ECMO also, right? So now everything was done, everything was prepared, and everything was done. So you know what how you are going to do. You have placed it center line. You have done all the machines. You have got all the required equipments and everything. So let's see how you are going to position these patients. So when you are trying to position a patient, especially for a VECMO or a VA ECMO, you need to have a sandbag under the hip. So technically, you are going to hyperextend the patient's hip here. So why? I'll tell it in the next slide. So along with the sandbag under the hip, the tracheostomy position, which we generally use for doing tracheostomy. So the same position. Some disturbance. Yeah, the same position should be kept even for your jugular cannulation also. So by doing these positions, what will happen now? So if you can see this slide, there is acute curve or acute turn of your IV. I mean, like the femoral vein that happens in the pelvic girdle. So if you're not going to correct that, sometimes the guide goes inside and hits it, and there will be higher chances of getting your IVC tear and going into retroperitoneal space. So try to hyperextend the hip whenever possible, and then so that your cannulation part will become easy. And then with every dilatation, make sure the blood is coming out of the dilator, so that makes sure that you are inside the vein. The same thing with the jugulars also. So that makes the positioning, the hyperextension of the neck makes the jugular tight, so that your cannulation part will become much easier here. So no need to apply more force, and you can do that. So this is how you need to drape this patient. So any procedure, as we say, it's the whole body drapes. Just expose the area where you're going to cannulate. Complete the whole body of the completely cover the whole body of the patient, starting from head to toes. Just expose 2 femorals here. So once you're going for cannulations, always expose 2 femorals. We don't know. So you might not get success only on one direct single shot cannulations. So try to prepare the areas and try to sterilize both femorals. Okay, so that in case one femoral site, if you have messed up, one femoral site, if there is a huge hematoma that's hindering the passage of cannulas, you can immediately shift to the other femoral site. So once again, you cannot remove the drapes and then prepare the sterile area of that left femoral also. So try to expose both femorals, try to make sterilize both femorals, and then try to prepare for both. So try to completely drape this patient. This is the reason why I am saying you need to have an extension for your center line, so that we know the drug is going inside the patient body. You cannot go there and then lift the drape and then give the drug there. So place a center line and keep an extension for the same. This is what I'm mentioning earlier in slides. And then position yourself in a comfortable way such that you don't need to turn this side and that side. So you should be always directly looking at your ultrasound monitor and then doing it in an ultrasound guided position. So you can see in this slide, he is so comfortable here, and then he's going to candidate the jugulars first. Okay, so that's how you're supposed to candidate any patient. If you're going to the femoral, the same thing. The machine should be on the opposite side, and then it should be easy way for us to look at. So once you're inside the vein, your guide wire is inside. Again, go to an echo probe and then make sure you get a four chamber view and the epigastric view, and then make sure the guide wire is inside your IVC. And then once the guide wire is still reached till to the point or the tip of your right atrium, that's the point you need to monitor the heart so that it will not go into any tamponade, and then you stop the guide wire advancement. Then you can go for dilatations. So once you dilate and everything was done, once your cannula was in place, so you need to have a bladder wash syringe pump, or you can have 50 cc syringes for continuous installation of saline from the top. And then you can go and connect to the two ends, one end of the cannula and then goes with the other end of the circuit. This is how you are going to connect the patients. So while you're going for cannulation, you connect the circuits once the cannulation is done. Okay. So once you have connected the circuits and everything, before going to fix it, so you need to fix the cannula, right, for the patient and all. Before you're going to fix it, you need to check the position of the cannula. So make sure the ECMO cannula stays inside the IVC. So the ideal position being the tip of the cannula should be at the confluence of your hepatic vein and the IVC. That should be the ideal position. You can see the blue line here, the flow of hepatic vein into the IVC, and then the flow of the ECMO cannula, like the flow, jet flow is going inside. So this should be your ideal position of IVC. Identify this position of the cannula and try to fix it with the holisters. So these are the holisters which are available. So these fixes very firmly to the skin, and then so once you fix with the holisters, okay, the cannula and the circuit is being fixed to the patient's limb. So some centers do have this, some center does not have this. If you don't have this, make a mark on the cannula positioning like 50 centimeters or 45 centimeters, something like that, and then try to make a suture on the thigh. So the cannula, the circuit is not going to come away from the patient's body. So this prevents the accidental decannulation or accidental, what is a disconnection of the circuit from the patients. So these are the basic things which are going to prepare when it comes to patient related. Circuit related, as already madam has explained, how to prime the circuit, what are the things that are required to be in the circuit. So everything you need to keep the things ready. Along with that, once, if at all, if you're using a blood priming, make sure you're using a torch and there are no no bubbles here. So the torch also should be kept ready. Even a heater cooler unit, blender that's connected here. So once that is done, what are the targets? So once you're done with the cannulation, where cannulas are in place, so you're going to attach the circuit. So what are the targets before attaching? So you need to have routine targets. Thus, I'm not going into routine targets, but only thing is your ACT should be more than 250 seconds at the initiation part. Okay, it should be more than 250 seconds at least. And then circuit ABG. If you are doing a blood priming of the circuit, okay, better to go for a circuit ABG. And even after that, once the circuit is done, the circuit connections are done and the patient is on ECMO, do a patient ABG also. Try to normalize, but don't try to overcorrect the carbon dioxide in a hurry. Okay, that's also important thing. Once the circuit is attached and everything was very normal, what are our targets now? Your ACT should be around 160 to 180 seconds. And ABG should be normalized in a period of around 1 to 2 hours or 3 hours time. Your hemoglobin target should be always more than 10 during the whole course of ECMO run. And platelet should be within normalized limits. So as and when you are planning for any procedure like tracheostomies and then or any decompressions or any surgical interventions, make sure the platelet count is more than 1.5. Okay. So just going to finish my talk here. Just what are the checklists till now what you have learned here? When it comes to machine, you need to have ECMO, you need to have ultrasound with all the probes, you need to have an ACT machine, ventilator, monitors, syringe pumps, heater cool unit, and blender. When it comes to circuit, yeah, one most important thing is these circuits are not interchangeable. So it's all the company related circuits. I think most of us, every one of us know that. So you should have the same company ECMO circuit, like Macket goes with Macket, Medos goes with Medos, and try to always carry some extra tubing, the 3A tubing around 10 to 20 feet, and try to always have some extra connectors. We never know when you're going to land up in a complication. So like a bleeding or a hematoma or leading to cardiac arrest, conversion from VV to VA. We cannot go on running here and there for the connectors. So always keep some extra tubing and extra connectors also, two straight connectors and two Y connectors, and keep an extra ambulance guide wire. Sometimes if at all if the guide wire got broken or something, not broken, if it gets bent and all, you need to have two dilator sets extra, like, and then cannulas. So one size below the measured size of the patient's vein, and priming solution is required. Patient, when it comes to the patient, you need to have the positioning pillows, wedge, measuring tape. So if you don't have an ultrasound or something like that, just measure from the tip of your epigastrium to your inguinal ligament. So that gives you a rough idea of where to place your cannula. And you need to always have two bloods reserved, any type of ECMO, whatever might be the hemoglobin. Better, it's better and safe to always have two bloods reserved. And you should always screen the vein or the artery for the size, and then the cannula length, which should be fixed. And you should always have the inotropes and drugs loaded. You cannot go on running here and there. And then you should always monitor the patient parameters also. So apart from all these things, equipments, when it comes to the checklist of equipments, drapes, probe cover belt, I think every one of us know this. I'm not going to in detail with that. Thank you so much for your patience. So any doubts? So I need to answer now.
A wonderful presentation, Dr. Rakesh. You have explained the content very well. If anybody has a question, we can take one question quickly. Otherwise, we'll move to the next talk. No question? Okay. So now I request Dr. Suvir Brewer, who is a consultant, cardiac anesthesia and critical care, and is actively participating in the ECMO program and has a vast experience of the ECMO at Hero DMC Heart Institute. We'll be talking about a protocol for cannulation. Because this is very important, as Dr. Rakesh talked about the initiation, arranging for everything, and now cannulation is something very, very important, because if you don't, if you're not able to cannulate, you will never be achieve that more. So Dr. Suvir will be talking about how we can do a safe cannulation. Dr. Suvir, over to you.
Okay. Am I audible?
Yes,
You
sir.
are
Yes.
you are
Okay. Okay. Thank you, Dr. Vic. So continuing with the topic, as Dr. Rakesh has actually just discussed the initiation of ECMO, and he has covered many aspects of cannulation also. I'll be just giving a brief view of cannulation and how we can go about it. The details we'll be doing on the workshop ECMO on 10th, but I'll be just covering the basics. So for protocol for cannulation, the establishment and maintenance of appropriate vascular stress is a prerequisite for ECMO. Unless we have a good vascular stress, ECMO is not going to work. So surgical approach used to be gold standard, but now we have moved ahead, and percutaneous or such approach is preferred now. And size and length of the cannula is very important, as we have seen that we need to have an appropriate cannula for the patient and for the underlying condition. Use of ultrasound and echo is a must now, and because we have to confirm the proper positioning of the cannula after insertion. So the various factors which depends our cannulation, choosing the right cannula is patient age and size, underlying disease and condition, and cause of the respiratory compromise. So depending on which type of support we will be using, we will be doing VV ECMO, VA ECMO. We'll be choosing the cannulas. So where to cannulate? We can cannulate either at the bedside or in the operating room, but mostly we are doing bedside cannulation nowadays. Advantage of bedside cannulation is that we can cannulate very sick patients, and risk of transfer is not there. No need to mobilize, and it is definitely faster. Disadvantage is that no access to fluoroscopy and less controlled environment, and sometimes space is the issue. In operating room, that is a gold standard, but again, and is a clinical environment. We have more experienced staff and fluoroscopy, but patient mobilization and unavoidable delays can be a problem. They can be issue with theater availability and resources of the war. So cannula size, what we have to choose according to the weight of the patient. So for venous and arterial cannulas, we have various sizes, and depending on the weight of the patient, we can choose the various size as shown here. So we can choose from 8 to 23 and 8 to 21, and depending on what patient we are dealing with. So we have to remember that we have to choose the largest possible cannula size, because flow is everything. If you have a good flow, we can achieve our targets. A small venous cannula will lead to low flow, and a small arterial cannula can cause hemolysis. Other factors like required flow, cannulation site, and vessel lumen diameter also help in choosing the correct dimension of the cannula. So, what are the different types of cannula design we have? Well, once we have a blunt tip cannula, this is a blunt tip cannula, and it has one central hole at the tip. Then we have a lighthouse tip cannula with the central hole with some distal side holes, and this is a lighthouse cannula. And multi-stage cannula is side holes at different stages along the cannula. This is a multi-stage cannula. And then we have interrupted multi-stage cannula with multiple drainage holes along the cannula, number 6, which is multi-stage interrupted. Then we can have a number of lumens. Maybe there can be one lumen, or there can be dual lumen cannula. Dual lumen for ECMO is with single insertion line. This is mainly used for VV ECMO. So they can come with different connectors also. So here we have different cannulas which are commonly used. This is the typical venous cannula, and this is the arterial cannula, and these are the insertion set. We have dilators and puncture needles and guide wires. So for VECMO, we have a peripheral cannulation or a central cannulation. For peripheral cannulation, we can choose a femoral artery and vein combination, femoral artery or axillary artery combination, femoral vein or axillary artery combination, internal jugular vein and a carotid artery combination, internal jugular vein or axillary artery combination. And for central cannulation, we have aortic and right atrium or aortic bicable. So what methods we use for cannulation? It is open technique is surgical cut down. We need a cardiothoracic surgeon for that. And for percutaneous, we use a Dinger technique, which is we percutaneously puncture the vessels. We place a guide wire and do serial dilatation. Commonly, we use it in VV ECMO. Then we have a modified Dinger technique. This is a disadvantage that we are exposed the vessels before doing the Dinger technique. So this is slightly more technically more practical. Central cannulation, in which we cannot do a peripheral cannulation, we have to do central cannulation. And this is a direct cannulation of the right atrium or aorta via thoracotomy. And usually patients who cannot come off CPB or which peripheral cannulation is not possible. So this picture shows open technique. This is, we can see the vessels exposed and we do a cannulation under direct vision. So direct cut down is done in ICU with full sterile preparation. Again, we need a deep sedation anesthesia or muscle relaxation in order to prevent spontaneous breathing. A local anesthesia may be needed to for dissecting the vessels, and we need to give heparin bolus of 50 to 100 units per kg just before cannula placement. That's technique, and here we can see the how is it done. We the puncture needle, we put a guide wire, then remove the puncture needle, we slide the cannula, and then we remove the guide wire. Shows, and this is used helpful in emergency situation. It's faster, and the risk of vascular convolution is less. So this is a typical percutaneous VA ECMO cannulas in place. So it does not involve any surgical SS. The skin forms a tight seal around the cannula, and so it decreases the chances of bleeding is quite less. So distal perfusion to prevent limb ischemia. Here we have put a distal perfusion cannula to prevent distal limb ischemia. So percutaneous cannulation can be done anywhere in ICU, cath lab, or does not need to be done in the OT. So OT team is not essential, but it has to be kept as a backup in just in case we need a cut down. If percutaneous cannulation is not successful, we place small conventional intravascular catheters and verify the position by blood sampling before putting the guide wire and doing serial dilatation. And we confirm the position by transthoracic echo, position of the guide wire. Then catheter is removed and followed by serial dilators, and then we finally do a large dilator and cannula is inserted. So here we need two people to do the percutaneous because one has to load the dilators on the wire and the one to load the vessels between dilators to avoid bleeding. So it is important to check the wire after each dilatation to look for any kinking, and we have to, if there is any kinking, we have to remove the wire. So we have to check the wire every time we do a serial dilatation. Heparin again bolus we have mentioned, we have to give after the main virus is placed, we give heparin bolus. So modified Salniker technique, here we can see that there is surgical cut down also, and we have inserted the cannula with the modified Salniker technique. So here again the vessels are exposed, and it is slightly more practical. It is again performed in various locations. It is vessel exposed by cut down, but they're not dissected. So again, the same procedure is done as is Saldigas. So the correct placement is performed by aspiration, and the dialectic exchange is lead to placement of the rectal cannula. The rest is same. The wound is then closed over the cannula, and this is treated like a percutaneous cannula. So the advantage is that we have a good speed, accurate assessment of vessel size, and flexibility of approach. So since we have seen the vessels after opening, so we have a good estimate of the vessel size. So for the distal vessel, is management of distal circulation after post cannulation. In the neck, we don't need distal vessel. It's not an issue because the collateral circulation to and from the head is quite good. But in femoral vessels, venous collateral is adequate, but femoral artery may significantly get occluded. So we need a separate perfusion line for distal perfusion of the femoral artery, and that is done by direct cut down or by Seldinger technique. This is the distal perfusion cannula. This is to perfuse the distal part of the leg, and this is very important in VECMO. Otherwise, it can lead to distal limb ischemia. Here we see the other configuration. This is the axillary artery and IJV cannulation. Here you can see the cannulas, both the cannulas in place. And pediatric cannulation is also very important. So here we can see the pediatric cannulas in place, and this is in the radiological view of the same. So for central cannulation, here we can see it, patient who are not fit for peripheral cannulation, or those who are not able to come off bypass, we have to do central cannulation. Here we can see the cannulas in place, and this is how it looks like. So the cannulas, the position of the cannula is very important. So here we can see this drainage cannula is here, and the return cannula is in the aorta. So for veno-venous ECMO, we have femoral combination, internal jugular femoral combination, and or directly internal jugular. So that we can use direct lumen, dual lumen catheter. So this is diagram which shows the femoral and IJV combination of the veno-venous ECMO. You have to take care to avoid recirculation in this configuration. Here we can see the placement of both the cannulas. This is the RA, and the lower cannula is in the IJV. So this is the double lumen cannula, which we can see here. This is a single cannula which has two lumens inside. So this is a single lumen which has both assess and return function. And this has two lumens for the drainage. This is bicular drainage, and return is through the RA lumen. So the advantage is that we can use single vein, and for the whole ECMO, this is one cannula is only used, and confirmation is usually through TE. Complication is that it can cause perforation, displacement, and the limitation is that there is a limited flow, and the cost is a factor. So this is a double lumen cannula in place, where we can see both the lumens, and one is the drainage, one is the SS cannula. Both are going to the same lumen. So cannulation failure is important. The inability to insert cannulas into the appropriate vessels, we have to explain the relatives before of this complication. So in that case, extracorporeal support will be not possible. And the reasons could be there could be morbidly obese patients, situation scenarios, and severe vascular calcification or scarring. So the main take-home message is the appropriate and uncomplicated cannula placement is the key to success, and technical improvement, especially improved cannula design, is a major contributing factor for successful placements. Complication can still happen, and it is a multidisciplinary team is essential for the success. Fluoroscopy and guidance is a must for percutaneous placement. And appropriate preparation along with the arrangement of blood is needed. And careful insertion technique and adequate training is a must. And close regular surveillance, and you should never panic and never force. Thank you.
Wonderful presentation, Dr. Suvir. You have explained the topic very well. Just one or two quick comments I'd like to make. That whenever we are preparing for cannulation, we should have actually a team divided who is managing patient, who is doing cannulation, and who is actually doing circuit priming. So the preparation, the team who is looking for the cannulation should ensure that they have the ECMO card, as we have a crash card. Similarly, ECMO card should be there, which contains every article in adequate amount, so that if one cannula or one wire falls down on the floor, at least you have a backup. You are not running for that. So that is very, very important. And whenever you come across a situation when you are not able to put a cannula, Never force it. It may be just a bad day for you. Ask someone else to put. Or if you have any issues, never hesitate to call the surgeon, gastro surgeon, so that they can be a great help and you can establish your end. So I'll ask someone if anybody has a question or comment on this.
Sir, I have a small comment
Yeah, please.
regarding the yes, sir. So it is regarding the choosing of cannula size. So we should not be one is we should not be over enthusiastic to put a largest possible size cannula because it will abut the vessel and so it will not suck the blood. Wow. That is
Very
one
true.
point I wanted to make, sir. And other point is it is better to instead of going by weight. Yes, there are charts are available. You can go by weight, but it is better to measure the size by ultrasound and then decide your cannulas. That would be a more better thing because majority of I'm talking about the pediatric perspective. It is majority of the patients are malnourished in our setup,
Very true.
so the weight may not be a appropriate.
Appropriate. Yeah, very true. Just looking for a size with using ultrasound. That's very important. And it's not that it's a bigger cannula, a bigger size vein or artery, so you have to put the biggest cannula. That's perfectly all right. Yes, that's very good answer. Anybody else? So we may proceed for the next talk. Dr. Suvir, now you can take over.
Okay, thank you, sir. The next talk is protocol for reticulation by Dr. Jayanti Kishore. He is a pediatric cardiac intensivist and director of Ecmo services for children and adult in Star Hospitals, Hyderabad. So over to Dr. Jayanti.
Hello, good evening, everyone. Let me share my screen. Can you see my screen here?
Yes,
can you all see my screen?
Yes, we can see the screen.
Yeah, thank you. So I'm just proceeding to the topic. Why do we need anticoagulation on ECMO? So basically, we are draining the blood from the body into the plastic tubings, PVC tubings, and the blood is returned back after oxygenation and decarboxylation. So blood is exposed to the artificial surface, unlike where we have a natural endothelial surface in the body where we have a balance of procoagulants and anticoagulants. This doesn't happen externally when the blood is exposed to the artificial surface. So we definitely need to anticoagulate to prevent clotting and problems on ECMO. So there is a constant exposure of blood to the surface, which initiates platelet aggregation, clotting, leading to thrombocytopenia. There is also in some patients there is a lot of inflammation. There is thrombosis, which we had recently seen this thromboinflammation in COVID-19 patients also. This all aggregates platelets and all, and it also consumes antithrombin. It limits the effect of heparin, so which all complicates the issue. So you can see that there is a protein adsorption on the lumen, then platelet adhesion and fibrinogen accumulation, and then there is a fibrin plug and thrombus formation, ultimately clogging the lumen of the circuit. This doesn't happen acutely suddenly like that, but it happens with time. So we need to properly monitor everything, anticoagulation, which we are giving to the patient, and then fine tune everything so that we avoid all this problem. So there need to be a balance. We already spoke about this, the thrombosis part with the platelet activation. And on the other side, there's a platelet dysfunction, consumption of the platelets, as well as coagulation factors, dissolution of the clot, which is fibrinolysis, the one Willebrand factor dysfunction, which all leads to bleeding. So we need to have a balance between these two pathways to prevent complications. So we just spoke about anticoagulation. We use heparin as an anticoagulant usually because it's widely used all over the world. And the heparin binds with antithrombin, which is there in the body. The administered heparin binds and forms a heparin antithrombin complex, which acts at multiple levels in the intrinsic pathway and the common pathway from fact. It prevents activation of factor 12, 11, 9, and the common pathway factor 10, and the factor 2A, from prothrombin to thrombin, and finally prevents formation of the fibrin plaque. So it is the most commonly used and has a short half-life. It is reversible. The action is reversible, and it's excreted by kidneys and reticuloendothelial system. So it acts by binding to antithrombin, and it inhibits most of the factors leading to its action. So the also recommendation for anticoagulation is given initial bolus of 50 to 100 units per kg, which is usually after the insertion of a guide wire, because if we give a bolus before the insertion of the guide wire or taking a puncture of the vessels, we can actually introduce a hematoma if we are not in the right vessel, or leading to more problems where we won't be able to secure the cannula properly. We won't be able to be in the right vessel, and it leads to a lot of mess finally. So ideally, it's better to take a puncture, insert the guide wire, and then give a bolus. Then start the patient on continuous infusion once the ACT falls. We'll come to ACT in the next slide. So once the ACT falls, we usually give bolus and measure an ACT. The ACT can go up to 600, 700, 800, depending on the patient's condition. And then once the ACT falls below 300 to 350 seconds, we start an infusion, usually around 10 to 20 units per kg per hour. And we try to achieve a therapeutic anticoagulation with a maintenance of a heparin infusion up from 20 to 50 units per kg per hour. So what is this therapeutic anticoagulation? So the target dose for the therapeutic anticoagulation is basically measured by activated clotting time, which is called ACT in short form. Usually we maintain it around 180 to 220 seconds, but we can also maintain a little lower in case of minor oozing or bleeding in some patients. You can see the ACT machine on the right and the container for the blood. Here we take the blood sample in this and immediately put into the ACT machine after calibration to the normal ambient temperature, and then calibration. So once this sample goes in, it reads the time duration for the clotting. So usually we keep it around 180 to 220 seconds. If the patient is bleeding severely, we may have to stop the anticoagulation for a few hours. There's no harm in stopping anticoagulation, especially in a new circuit in the initial stages of ECMO if bleeding is a problem, and then restart gradually as the bleeding stops. The ACT is monitored 2 to 4 hourly, and once if the ACT is quite stable and acceptable in the range we target, we keep it. We monitor around 4th hourly, but otherwise we may have to monitor very closely 1 to 2 hourly also. With the ACT, the problem with ACT is it's sensitive to a lot of things like platelet counts and function, as well as factor deficiencies, ambient temperature, hemodilution, hypothermia, etc. Is falsely elevated in hypothermia and hypofibrinogenemia and thrombocytopenia, and it is falsely low in hyperfibrinogenemia and thrombocytosis. It's the easiest bedside point of care test. It also correlates better in patients receiving high dose heparin on cardiopulmonary bypass. But in long-term ECMO, due to prolonged inflammation and deficiency of coagulation factors, we may get wrong results. So when we say there are a lot of fallacies with ACT in certain patients and certain scenarios, what is the next other alternative test? APTT. So APTT is another test which is usually kept. Usually it's around 25 to 35 seconds, but again it depends on the laboratory, reagent, equipment used, and a lot of technical aspects and a lot of biological variables. And it also is sensitive on sensitive to improper collections, anemia, thrombocytopenia, lupus anticoagulant, factor deficiencies, inflammation, a lot of other things. So it's again not always reliable. Sometimes it correlates well with ACT, sometimes it doesn't. So we cannot completely depend on this also. This is just, I found this as a rough guidance. that we cannot correlate APTT, ACT always, as I said in the previous slide. But if ACT is low or APTT is low, very low, we give usually a heparin bolus and titrate the infusion rate also. But if it is in the normal range, there's nothing need to be done. If it's going up and up and up, either ACT or APTT, then we have to reduce the heparin dose and titrate it gently. And then, but if the values are abnormal, we may have to we may have to monitor the ACT and APTT very closely. Usually, the ACT is done more frequently, but the APTT is done once or twice. And the problem with APTT is it takes time, and it all the storage time also matters, and the collection time, the transfer time to the laboratory, the processing time, then it all takes long time. And if the sample is stored for a long time, it again gives a false value. There'll be a lot of error in that. So we need to keep in mind all these things before we actually trust the values. So what is even a better monitoring parameter is anti-10A. So anti-10A gives more consistent result than those both. And it is usually measured in international units per ml, and it's between 0.3 to 0.7 international units per ml. It is not affected by the age or coagulopathy. And it also needs it doesn't need local calibration, and it is basically not dependent on the type of equipment or the reagent used. It again is how much it correlates with ACT and PTT is again needs to be established. As of now, not it is still not very clear, but there are some studies showing some correlation between these two values, APTT and anti-10A. I'll show that. It's not easily available everywhere, so people still depend on ACT and APTT. And in the West, it is more easily available. So if you see this chart, these and on the x-axis is the anti-10A, and on the y-axis is APTT. So the range is between 60 to 80 here for the APTT, and 0.3 to 0.7 for the anti-10A. If you see here, there's some values hovering here. That is the ACT, sorry, anti-10A is low as well as the APTT is low. So that means it is correlating here, and it is if the if the anti-10A is low, but IPTT is still in the range, it is not correlating. So there are some values here which are not really matching. The IPTT is in the range, but anti-10A is still low. There are some values here where it is matching. APTT is in range, and anti-10A is also in range. And here it's all over the place. So we can't trust on these values. So it's hardly like around 40-45% correlation, and the rest of the values don't correlate. So why does it happen? We'll talk about that. So anti-10A is also dependent on certain things like sample transparency. If there are hemolyzed or opaque samples, it doesn't again give a normal result. It can cause falsely low values if there is a high bilirubin or high triglyceride levels. And if the patient is already on some other anticoagulant previously, recently, like low molecular weight heparin or something else, it can again interfere with the results. So if the APTT is low or high, but the anti-10A is normal, if you actually depend on the APTT nomogram, you can end up in either thrombosis or bleeding. So anti-10A is more reliable in such situations where we have out of proportion APTT is in low or high, but anti-10A is in normal range. Why is that? Because APTT is affected by factor levels like fibrinogen factor 8 levels, etc. And then it can be falsely elevated sometimes. It can be elevated. The difficulty in achieving target. Oh, sorry, this is, difficulty in achieving target anticoagulation. It can be because of antithrombin deficiency, because heparin is dependent on the antithrombin levels. If the antithrombin levels are less than 60%, there is the likelihood of heparin resistance. So we can't believe on that. If your heparin is going up and it's doubling up and you're still not able to achieve the anticoagulation, you need to look into the factors causing this. It can be antithrombin deficiency. It can also be due to the clearance of heparin to the urine or the CVVH. And if you had recently transfused FFP or cryo or platelets, it can affect again, and can have resistance to heparin. If you have high levels of factor 8 or fibrinogen, again, the APTT is reduced. So we have to keep in mind all these things before we make a decision. So what do we do for antithrombotic deficiency? Usually we don't. Sorry. So usually people transfuse cryo. In the West, there people also used to transfusing antithrombin by measuring the antithrombin. There is a formula also for measuring, for actually for the replacement, how much to replace. There is a formula. Measure the antithrombin, and you also have a desired antithrombin, and based on that you do it. But there is some literature also not supporting this, because people have found that even after replacement of antithrombin, there is not of much use. So we already have, coming to this algorithm, we have already given a bolus. We've maintained on the continuous infusion of heparin. So if you found a discrepancy in APTT and anti-10A, suppose the APTT is increased but the anti-10A is in range, please follow the anti-10A, because APTT is again dependent on so many factors and the lupus anticoagulant, presence of the lupus anticoagulant in the blood. If both are low, we can increase the heparin dose. If both are high, reduce the heparin dose. There's another protocol from Freeman Hospital where I worked. So if you have a low ACT, there's no bleeding, you check for the anti-10A. If there is normal anti-10A, just slightly increase the heparin, but there is no need to give any bolus. But if it's low, they'll have to increase heparin and give a bolus. Then if it's still low, look for the antithrombin resistance and other issues. If it is high, then exclude factor deficiencies, platelet deficiencies, and the other issues. Then recheck after replacement of the products. Then if it's still high, look for fibrinolysis and do the antifibrinolytics. So if a patient has hemolysis or liver failure or DIC or any other coagulopathy, people also do TEG and TEG or ROTEM. In fact, in TEG, the cup rotates, whereas in ROTEM, the pin rotates. Basically, it's based on impediment and to the resistance to the pin and the cup. So based on that, there is a graph is created. And we have these graphs, which is a normal graph, which resembles a brandy tumbler. You can see this is the R time. And we're not going to teach TEG here, but anyway, I'm just going to show that there is the R time is this, and this is the MA, the maximum amplitude, and later comes the lysis part. So if R time is prolonged, it means that there is a factor deficiency. If the MA is reduced, either there is platelet deficiency or there's a platelet dysfunction. If there is a clotting followed by lysis, this is fibrinolysis, we have to give antifibrinolytics. This is hypercoagulation seen in certain conditions. And in stage 1 DIC, you see hypercoagulation followed by lysis. And in stage 2, there is a prolonged R time and also reduced MA. So that is all hypocoagulable, low platelets, factor deficiency, and everything. So this gives a rough idea of what is deficient, and we can replace the products as well as monitor all the anticoagulation tightly. So we have already spoken about the heparin resistance. If there is a persistent reduction in the platelet count, we need to look for a sepsis, as well as if sepsis is ruled out, any other cause of reduction in platelet is ruled out, we have to suspect a heparin-induced thrombocytopenia and send PF4 antibodies. If they are positive, we need to switch to alternative anticoagulants. If there is a thrombus, look for the causes like DIC and HIT or antiphospholipid antibodies, etc. If there is bleeding, look for the causes of the bleeding. So, direct thrombin inhibitors. Direct thrombin inhibitors act via direct thrombin inhibitors. They act exactly here. They don't act in the ascending path. They just act at the terminal path here, and then cause their effect. So the half-life of bivalirudin is around 25 minutes and argatroban is 45 minutes. But unfortunately, there is no antidote for this, unlike heparin, which has got an antidote, protamine here. Okay, so in HIT, these are used. But if there is any bleeding with this, we can stop this and it gets reversed after some time. Okay, so if there is a major bleeding, we can use factor 10, factor 7A, which is a recombinant factor. The dose is around 40 to 90 micrograms per kg, and lower doses also can be administered in certain patients. There is a chance for clotting of circuit. The entire circuit can clot suddenly. So we need to be ready with the new circuit if we are administering, and it's very risky. So usually this is not advised, and it's not advisable to use this unless it is out of control. So we use anti-fibrinolytics like aminocaproic acid or tranexamic acid in scenarios where we have to actually do some procedures like ICD insertions or lung biopsy or any other, or if the patient is prone for bleeding due to any complication with predisposing factors. In such situations, where we use these drugs. So we are almost coming to the end of the slides. So what are the possible circuit modifications for future? So the endothelins produce prostacyclin, nitric oxide, and matrix metalloproteases, which actually inhibit the platelet adhesion and activation. So that actually maintains the fluidity of the blood. So in presence of these inhibitors, their platelets are inhibited. So we need to introduce something, some kind of these kind of chemicals into a natural surface, which mimics the natural surface in the artificial surface, which releases the nitric oxide gradually. Because again, nitric oxide is the half-life is very short. It doesn't stay long in the blood. It doesn't also cause systemic effect. So something like nitric oxide, which produces nitric oxide and is very naturally releasing all the time, we need to choose such a circuit. So I think studies are going on this, and probably we'll get something like this in the future, which acts like a natural endothelium rather than an artificial surface which predisposes to inflammation and coagulation pathway. The summary is we need to have a balance between the procoagulation and anticoagulation. So ACT is the easiest bedside monitoring test for anticoagulation. APTT is again unreliable due to fallacies involved. Anti-10A is more reliable, but it is not easily available. At the same time, it is expensive. There is no correlation established between ACT, APTT, and anti-10A in most of the times. In such situation, first, if we have availability, we need to give preference to anti-10A. And in cases of HIT, we need to go for direct thrombin inhibitors to have a smooth run of Ecmo. Thank you.
Thank you, Dr. Kishore, for beautifully covering all the aspects of anticoagulation for Ecmo. If there are any questions from the audience, they are welcome. I guess we have all the discussion in the workshop eventually on 10th. So moving ahead with the next lecture. This is by Dr. Sunil.
Thank you.
Thank you very much, sir. So next lecture is by Dr. Sunil Karant on protocol for initiation. Dr. Sunil, he is chairman and head of critical care, Manipal Hospital, Bangalore. Over to you, Dr. Sunil.
Thank you. Can you hear me and can you see the slides?
Yes, we can hear you and we can see the slides also.
Thank you. Good evening, everyone. Thank you, the organizers, for giving me this opportunity. So, protocol for initiation. What is initiation? Essentially, it comprises of the process of establishing the patient on ECMO. Now, it could be VA, VV, and gross general protocol remains the same with some minor modifications in each of the types or modes of ECMO. So as we all know, 3 types of ECMO. I'm sure you've gone through this over the last few hours. VA for circulatory support, VV for veno-venous for respiratory support, and the ECMO CPR. Now, when do you choose ECMO? Of course, when we talk about initiation, it's important to get the indications right. This has also probably been already discussed, and some of the things that I will be talking about will be just summarizing what you have already gone through the entire day. Essentially, when we talk about choosing ECMO, 2-3 important criteria as that it has to be considered in the appropriate patient who is of a reasonably young age. Now, it could be relative. The definition of this age can vary. Of course, less than 65 years is what is recommended, but up to 75, you could extend if there is no other contraindication or no other specific comorbidities, wherein there is a potentially reversible cardiac or respiratory failure. Now, that is important. So when we talk about initiating protocol, it is important to get the indications right. And in a person in whom the conventional standard levels of support is crossed and there is a reasonable certainty of the patient surviving, as we call as reversibility, and of course early rather than later in the natural history of the course of the critical illness. So in short, the summary of this slide is that a relatively or young patient in whom we suspect or we expect there is reversibility of the pathology and a bridge to something. It is either bridge to cure, bridge to transplant, or any other form of longer term modality support. Now, when we talk about initiation of ECMO, certain important factors that need to be considered. It starts with patient factors such as age, as we already discussed, comorbidities, which wherein there is again a comorbidity where it is not such a comorbidity which leads to terminal illness, no frailty, patient's wishes, patient's anatomy, of course. So, when we talk about somebody who is very obese or who has peripheral vascular disease or such other vascular anomalies, it may be problematic to do the ECMO. And of course, whether there is a need for inter-hospital transfer. We also take into consideration factors such as diagnosis and the clinical state, wherein the main thing would be to consider that there is appropriate reversibility, the diagnosis, duration of disease, speed of progression of the disease, and organ failures and severity of illness. Now, coming to the initiating protocols for VA ECMO, the patient eligibility for VA ECMO is extremely important. Now, until now, I spoke about the general sort of principles of initiation protocols. Now, I'll be getting into the specifics. The eligibility for a VA ECMO is to ensure that there is, we determine that the risk score, there are different forms of risk score, but we ensure that there is optimal risk score by combining the scores from the diagnostics of the patient and is there any clinical modifier, and to ensure that there is no absolute contraindication and establish eligibility and expected outcome for VA ECMO support. Now, there are a number of eligible criteria. Now, essentially what we need to understand is that there has to be a favorable diagnostic score wherein there is certain amount of there is reasonable extent of reversibility, and in that context we talk about either a myocarditis, a cardiomyopathy with its first presentation, pulmonary embolism, drug overdose, primary graft dysfunction, post cardiac transplant, ischemic VSD, post AMI, and high risk diagnostic categories such as or it could be a high-risk diagnostic category where the likelihood of benefit may be much lower and you have a score which is 2. Now, this is a score I've taken from one of the ECMO centers. You could have your own score, or you could look at essentially assessing the degree of reversibility. Now, this is a slide to just indicate how do we assess the risk of or the prognosis or the likelihood of reversibility and the risk and benefit of putting the patient on ECMO. And if there is a more unfavorable diagnostic category, then you need to really think twice before the ECMO is actually initiated. The second important consideration would be what we call as the clinical modifier, or those comorbidities where you would consider that the likelihood of benefit substantially reduces. Now, both these factors are taken into consideration when we decide on the indication of ECMO. Rule out absolute contraindications such as age above 75, terminal illness, non-treatable cancer, cirrhosis, chronic kidney disease, advanced COPD, advanced organ failure, anatomical considerations, and certain acute conditions which is already very advanced wherein there is multi-system organ failure, and the benefit of the ECMO is unlikely to be of benefit. And of course, if there is signs of significant brainstem dysfunction or fixed dilated pupils. Now, all these can be plotted on an eligibility chart or on any other format where we ensure that the balance between the risk of putting the patient on ECMO and the likelihood of survivability is reasonable. Now, apart from the likelihood of success to recovery, we also use ECMO or VA ECMO as a bridge to transplant or LVAD when there is and do we have when we have acute decompensated heart failure in a patient with chronic heart failure, wherein there is a bridge to transplant or a bridge to LVAD. Again, look at absolute contraindications. It's very important here to ensure that the success of bridging would be to something like an LVAD, which is a long-term bridge mechanism, or to transplant. Usually, converting patients directly into LVAD is associated with poorer outcomes. So, in patients who come with decompensated heart failure, it is always we always do commence them on either ECMO or other forms of bridging therapy like Impella before they go on to long-term LVAD. Assessing the pre-ECMO risk predictions is important to, one, ensure that the benefit of ECMO is reasonable, and also to categorize the risk stratification. So there are a number of scores. So you could actually choose. I request people to go on mute, please. So essentially, SAFE score is one of the commonly used scores to ensure to risk stratify and to categorize the likelihood of survival in patients go on VA ECMO. The second mode of ECMO is VV ECMO, where again the same principles are used. Determine the risk of combining scores, where you consider what is the diagnostic reason for why the patient goes on ECMO, and look at comorbidities or clinical modifiers which may further determine the prognosis of the patient going on ECMO. Ensure that there is no absolute contraindication, and to establish the eligibility and expected outcome based on various criteria. Here again, we look at reversible factors which have a favorable diagnostic criteria, such as infective pneumonias, aspirations, pneumonitis, status asthmaticus, primary graft dysfunction following transplant, especially if it is early within 7 days, ARDS of any form. More high-risk categories include necrotizing pneumonia, lung transplant beyond the first week, traumatic injuries, moderate traumatic brain injury with associated lung injuries, and more unfavorable diagnosis such as pneumocystis, lung transplants after a month, or invasive fungal infections. The clinical modifying criteria here would include, clinical modifiers would be chronic diseases which would actually negate or which would reduce the likelihood of benefit from ECMO. So all these are actually put into a scale, and we actually decide the likelihood of benefit. So essentially, the bottom line is to ensure that there is reversibility, the benefit is likely to be greater than the risk, and ensure that we bridge the patient to something, either to cure or to transplant. I think this is the fundamental principle on which VA or VV ECMO would be considered. Contraindications for VV ECMO would be severe advanced chronic problems, chronic lung diseases, wherein the likelihood of transplant is not there, or we use this as a bridge to transplant. And again, look at various factors where there is irreversibility to the transplant, irreversibility to the underlying lung pathology. Essentially, also important to choose the patient profile: advanced age, advanced terminal illness, malignancy, cirrhosis, severe brain dysfunction. These are all relative or absolute contraindications to choose. Here again, we scale these patients on an eligibility chart, and those patients who would fall in this green category here would be considered as appropriate and more likely to be benefiting from ECMO. So it's important, as I said, to choose the patient appropriately. ECMO CPR, variable outcomes. The important inclusion criteria is to look at age plus time in minutes. Essentially, the time of arrest should be within the hour, and we ensure that it is a witnessed cardiac arrest with a shockable rhythm, and bystander CPR commenced within 5 minutes with no evidence of any end-stage disease. So here again, we assess the important thing is to assess the reversibility and to ensure that there is no end-stage disease, and the benefit of eCPR is at least reasonable. Factors that would exclude patients who would benefit from eCPR or who would be relative contraindications would be age, end-tidal CO2 less than 10, wherein there is difficult cannulation either in terms of the venous or the return or the access cannula, and presence of pericardial tamponade, the suspected dissection. So these are some of the indications on which we would decide VA, VV, or ECPR ECMO indications to go on to ECMO. Now, how do we set up the ECMO console? Again, could be a summary of what we have already seen. Ensure that the circuit is primed. In those centers where eCPR is a format, they generally do have a primed ECMO kept running and ready to go. So ensure that you prime the ECMO either with saline or blood, depending on the hemoglobin and the indication on why ECMO is being considered, and wheel the primed circuit into the ICU. Start the ECMO power connections. Here again, it's important that the power connection goes on. Whenever you go on to the power connection, the power connection light comes on, and you find that the battery charging light comes on till the battery gets completely charged. So it is very important to ensure that the AC power connections are switched on. And as a safety mechanism, ensure that the hand crank is loaded and fixed by its clamp very close to the ECMO pump, so it is accessible and in close proximity to the pump head. The next step would be to ensure that the circuit is fixed into place with the appropriate positioning of the pump head and the oxygenator. It is always that the pump head is kept tilted above the level of the oxygenator, and the necessary transducers are placed at the level of the patient bed. So this is the setting up of the ECMO, and set up the oxygen connection, which is the green tubing, which enters, one end of which enters the membrane oxygenator inlet, and the other end would be connected to the oxygen source on the wall. Running the primed ECMO is important before we connect the patient onto ECMO, as the cannula is being done. So the running of the primed ECMO is done on the machine or on the console to ensure that there is optimal functioning of the ECMO, an air-free circuit, and appropriate flow readings, and warming of the prime circuit to the body temperature. So this is actually a trial mechanism by which we ensure that the ECMO is optimally functioning. Certain other things that we do is to make sure that the flows are recorded. This is done by ensuring proper adequate ultrasonic paste on the flow sensor on the pump head. If the flow is not indicated, or you get 3 dashes to say that, or the flow is showing a 0 in spite of the pump functioning, redeploy the disconnect the pump, reapply the ultrasonic gel, and again reattempt running the ECMO on the console with the prime fluid. Release all the clamps and run the ECMO at about 1500 to 2000 RPM, and look for any air bubbles, any agitation, etc., to ensure that there is smooth flow of the saline or the prime fluid within the ECMO circuit. Once all this is set up, place a ECMO pump clamp on the ECMO circuit, which is immediately post oxygenator, and return the pump to stationary or 0 level, and keep the alarms silent and ECMO ready to go. At this point of time, you'd also clamp the red and blue tubings, because this is the point where the very close to the proximal reservoir bag, and await handing over of the circuit for connections. Once the priming is done and we are ensured of the smooth flow of the circuit, or the smooth flow of the functioning of the ECMO console, set up the warming circuit to a temperature of about 36 degrees, and make sure that the flow signals are zeroed appropriately. The zeroing is done by clamping the circuit post oxygenator, as already mentioned, and we actually reduce the pump flow to 0 and press the zeroing button for about 3 seconds till the 3 beeps occur, and you actually find that the 0 comes on the flow reading, which indicates that the ECMO is ready to go. Once the initial settings of the console is done, gradually once the initial setting is done, the ECMO is ready to go, and once the person who has, or the operator who is actually inserted the cannulas are ready, you ensure that there is optimal connections which are done. The connection has to be, when we start the ECMO, choose the ECMO settings to the lowest, about 1500 is what we start with. And so the usual recommendation is to start the initial oxygen flow equal to the blood flow, so there is no rapid reduction of the CO2 resulting in alkalosis or other acid-base disorders. Start at a rate of around 1500 to 2000 and then gradually escalate the flow guided by the ABG to ensure that there is no rapid reduction in the CO2. So depending on whether it is a VA or VV, the flows are obtained to either ensure optimal oxygenation, as in the case of VV ECMO, or optimal hemodynamic support, as in the case of VA ECMO. Now, avoiding large or rapid escalations of the sweep oxygen is important to ensure that the CO2 reduction doesn't happen rapidly, so that we do have there is no there is no hypocapnia or other forms of acid-base problems which do happen. This is particularly important when we talk about patients who are having severe ARDS or who have elevated CO2 levels and end up going on VV ECMO. The final manipulation of the CO2 or the sweep gas will be determined by the patient's catabolic state and the actual underlying CO2 production. The circuit connections are optimized, and once you ensure that the patient is ready to go, you ensure that the entire circuit is de-aired and give the connectors to the person who has inserted the cannula. At that time, it's very important to ensure optimal matching so that the arterial end ends up to the arterial side of the flow and the venous end to the venous side. So final checks prior to going is important. Mandatory checks need to be done by the cannulator, because he is the person who would be having the last go as the patient gets on to the ECMO. Perform all the necessary underwater seal. Once the patient is on ECMO, start with an RPM of 1500 and gradually increase as per the patient needs. Confirmation is often got by the visual direction of the blood flow from the access cannula to the pump head and the color chain that runs across the oxygenator, ensuring that there is optimal gas delivery and function. Of course, after this, you would also look at the patient's hemodynamics, saturation, and the subsequent ABG, which will ensure optimal maintenance of the ECMO. Thank you.
Thank you, Dr. Sunil. It was an excellent and comprehensive protocol for initiation, and I think everybody is greatly benefited. So any queries from the audience? Okay, I think we can move it to the next lecture. It's by Dr. Saurabh Taneja on protocol for monitoring. Dr. Saurabh is a consultant at Sri Gangaram Hospital, New Delhi. So over to you, Dr. Saurabh, for protocol for monitoring.
Hello all. Am I audible and visible?
Yes, you are audible and visible too.
Thank you so much, Dr. Subir, for the kind introduction. So I work at Sir Gangaram Hospital, New Delhi, and I'll be talking about protocol for monitoring an ECMO patient. So I'll be covering why is monitoring actually important, especially in a case of ECMO patient. What are the important things to monitor in case of pressures, the gases? Why is revolution per minute vis-a-vis flow very important to monitor? The laboratory parameters, radiology and 2D echo, especially in a patient of ECMO. So in ECMO patient, we have two circulations. One is the native circulation of the patient and one is the ECMO circuit. So we have to monitoring can also be divided into two, patient and circuit. And we have to familiarize with the equipment of ECMO, because some life-threatening complications can actually occur when the patient is on ECMO. And if you actually monitor the patient well, you can prevent many of these complications at a very early stage and save the life of the patient. Now, first is the pressure monitoring. Dr. Sunil has made my life easier about talking about initiation and zeroing, etc. So we zero the transducer first. and we prefer radial lines, especially in case of VA ECMO. We have to monitor the right radial ones because it has a native flow. Remember, ECMO is a non-pulsatile flow as compared to our native circulation, which is a pulsatile flow. So if you find a pulsatile flow in arterial waveform, that means the native circulation is predominant. And remember, as the flow increases in ECMO, the damping of arterial breathing does occur, as can be seen in the below image. Now, three pressures have to be monitored: the pre-pump pressure, the pre-oxygenator pressure, and the post-oxygenator pressure. So pre-pump pressure is usually around minus 20 to minus 30 is taken as a point where you have to raise an alarm. That means that there is either a low volume, inadequate cannula size, or a poor catheter size is there. And things like shattering can be seen. That is a trembling of the catheters. Then pre-oxygenator pressure, it shows that increase with increase in resistance. So the causes can be smaller size arterial cannula, increased systemic vascular resistance, kinking of tube. So there are no fixed values of pre-oxygenator and post-oxygenator pressure. But the difference between the pre and the post is called the delta pressure. And if the delta pressure increases, that means there is increased resistance in the oxygenator. And most probably there is a clogging of the oxygenator and some clots can be there. We should set alarms wisely. We should monitor the patient, see what are the normal pressures that the patient is keeping, and then set alarms. So this is a common circuit in which we can actually see this is a drainage cannula. So this is a pre-pump pressure, this is a pre-oxygenator pressure, and a post-oxygenator pressure, and the difference is the delta pressure. Now monitoring the blood gases, the saturation, keep probe in the right hand intermittently, especially in case of VA ECMO, again to see whether their circulation is a native one or the oxygenated VA ECMO circulation. So the target saturation for VA ECMO is usually 100%, and in case of VV ECMO, we accept around 85%. The SCVO2 in case of VA ECMO is more than 70%, whereas it's not that reliable in case of VV ECMO. This tells us about the hemodynamics, and VA ECMO, the main aim is to improve the hemodynamics. Now, another thing to monitor is the revolutions per minute. So again, we set the revolutions per minute, and that is how we set the flow actually. So ideally, at a constant revolution per minute, the constant blood flow should be there. But this actually does not happen. We should monitor it every hourly, as well as if any change is there, we should think why is the change. So in the below table, I've highlighted if there is a decreased flow with the same revolutions per minute, that means there's either increased resistance or decreased preload. So decreased preload can be the position of the cannula might have changed. There can be hypovolemia or there can be kinking of tubings. Whereas in case of increased resistance, again vasoconstrictions, kinking of tubing, hypertension or obstruction in the circuit may be there. If at the same RPM the flow has increased, the arterial cannula may have migrated to a better position, or there is an increased preload by increased patient filling. So you have to correlate the revolutions per minute and the flow and compare it to the previous ones. That is why you need to chart it. The centrifugal pump is a preload and afterload dependent pump, and that is why these changes happen. Now, vital parameters in the patient: the heart rate, the temperature, and the respiratory rate. But especially in case of a ECMO patient, neurological status is a very important thing to monitor, as we are anticoagulating the patient. And a life-threatening complication is the intracranial bleed. So pupillary reactions should be checked every 2 hourly, and the level of consciousness should also be seen by giving a sedation-free period at least once every day, as soon as the patient is stable, or we can actually give it. Now about ECMO settings, the blood flow rate can vary from 80 to 120 or 150, and high blood flow may cause hemolysis or increased afterload. The gas flow rate ideally is kept around 1 is to 1, but usually the range is 0.5 to 1.5 is to 1. And this gas flow rate will be divided by the carbon dioxide level that we want to keep. Now, settings of the heater cooler unit should be checked hourly, and we should adjust the temperature. Analgesia and sedation of the patient is still required, and this is the circulation has increased, so maybe those requirements increase in such a patient. Especially the urine should be monitored for hematuria or hemolysis. So urine output and color both should be monitored. Now these kind of patients assess peripheral circulation, especially in VA ECMO. So in VA ECMO, we have to check for ischemia on the side and which we are cannulated, especially when we have done a groin cannulation. We should check the limb for peripheral pulsation, the color of the limb, the capillary refill, and if the limb is having some edema. Check for discoloration and ischemic signs, and we can actually use the ultrasound Doppler for flow measurements. So these are pictures of limb malperfusion and no backflow in the cannula. That is why we put a reperfusion cannula to reperfuse the limb in which we have cannulated the femorals. So the dreaded complication is foot ischemia and gangrene, and we should prevent this. So serial monitoring of the limb by ultrasound, by the temperature difference, by seeing edema and skin changes is a must. Now checking the cannula position. So entire circuit, the connectors should actually be checked in every shift. The dressing should be checked. They should be transparent. There should be no leakage. There should be no side infections. And horizontal tubing attachment devices are there. Especially a torch light should be passed through the circuit to look for small clots that can actually be occurring. So that can be done every shift. The color difference should be appreciated between the two limbs. And as we can see, if we use a torch, we can find out abnormal clots in the oxygenator in the very beginning. Now, some laboratory parameters that we need to monitor. Usually, we have a ACT level. We do before initiation because we give a anticoagulation at this time after 1 hour of initiation. And if it is stable, we have to do it 4 hourly. But if the unstable values are varying, we can do it 1 to 2 hourly. If we plan a procedure or the patient bleeding, we have to do it more frequently or as and when required. Now, these are the causes of the elevated levels and decreased levels of ACT. Now, elevated levels can be because of excessive heparin dose, underlying liver kidney disorder, thrombocytopenia or hemodilution. The bleeding tendency is increased, and we have to manage by decreasing or stopping heparin and monitoring it more frequently. Now, if ACT is not available, we'll have to monitor the APTT levels. The normal range is 35 test and 32 control, and we need to keep it between 60 to 90 seconds. The PT levels we have to monitor once in 3 days, but usually do it every day because we are anticoagulating the patient and we don't want a PT to be deranged, and we can actually pick up underlying liver disorder much early if the PT is deranged. There are defined guidelines by ELSO for anticoagulation and when to monitor it. Now, hemoglobin should be monitored before starting ECMO. After 4 hours of starting ECMO, then we can gradually do it twice a day or as and when required. Platelets should be monitored twice a day. There are many causes of decreased level of platelets because we have an entire circuit in which the platelets can be broken down. And if the patient is having a CRRT along with the ECMO, there are more reasons for the platelets to be broken down. Plus, the patient can have a heparin-induced thrombocytopenia. Again, the ELSO guidelines tell you about the blood product goals and the replacements and what are the levels that you need to monitor, and we should all be clear in this. Now, antithrombin 3 levels should be done once in 3 days or whenever heparin requirement increases. It is considered the most important inhibitor in the coagulation cascade, and the levels to be maintained is more than 70%. And this is a must for the action of heparin. Anti-factor 10A can be done in some places. It should ideally be done once daily, and the normal range is 0.3 to 0.7 units per ml. And it is used to measure plasma level of heparin and to monitor anticoagulant therapy. Now, the latest at some places we have a TEG or a ROTEM, which is a non-invasive test, which can be done every day, and it measures the quantitative measure of the ability of whole blood to form a clot. It actually measures all phases of hemostasis. That is the best part. The thrombosis, the fibrinolysis, and if you can actually decipher it, it can tell you whether deficiency is in the platelets or in the coagulation factors or in fibrolysis. And according to that, you can actually treat the patient. Renal function test should be done once daily and can be increased in pre-renal or renal failure. Cause of pre-renal failure can be hypovolemia or low cardiac output or a non-pulsatile flow that is there in ECMO. Causes of renal failure can be acute tubular necrosis due to hypotension and hypoxia, sepsis, or some drug induced. Electrolytes need to be monitored like sodium, potassium, and calcium. Sodium should be twice daily, potassium should also be twice daily, and ideally in an ECMO patient, we monitor the ionic calcium. Magnesium we can do once in 2 to 3 days. Now, arterial blood gas analysis should be done before starting the ECMO, 1 hour after starting the ECMO, and 4 to 6 hourly if unstable. Or at least usually we do it once a day or twice a day. In all practical purposes, we do it twice a day or maybe multiple times a day. Now, we should also monitor the plasma free hemoglobin. It should be done once in 3 days or as and when required. And there's an alarm if it is more than 30 milligrams per deciliter. The causes of elevated levels are intravascular hemolysis by excessive negative pressure by the centrifugal pump or the heat generated by the pump. Excessive occlusion by the roller pump in the erstwhile days caused it to be elevated. Any clot in the pump or oxygenator or a small size cannula can also lead to elevation. And the effect is that decreased hemoglobin and platelets, increased bilirubin level due to breakdown of hemoglobin, or renal shutdown. So in these patients, we need to maintain good hydration, maintain an adequate urine output, and if the level is more than 40 in dire circumstances, we need to change the entire circuit. Now, bilirubin level should be done once in 3 days and inform if it is more than 3 milligrams per deciliter. And the causes can be hepatitis or a cholestasis, which is sepsis-induced or obstructive jaundice, but especially in case of ECMO, hemolysis can also be an important cause. Now, lactate levels, usually done in most places in the blood gas analysis or point of care, should be done before starting the ECMO, 3 hours after initiation. In a VA, ECMO should be repeated every 12 hourly for the first 2 days at least because it's a marker of hemodynamics. Lactate is one of the earliest marker of recovery. The elevated levels can be because of tissue hypoxia, renal or hepatic failure, and pseudo high levels can be in adrenaline infusion. Now, procalcitonin levels, whenever an infection is suspected or there is sudden deterioration in the condition of the patient, because in our country we've seen that prolonged ECMOs may cause some kind of infection at the sites or due to bloodstream infections. So, procalcitonin levels help us to catch the infection up early. Then we can, the normal age is less than 0.5, but we should raise an alarm if it is more than 2. And it has also been, according to the guidelines, been used for evaluation of response to antibiotics and de-escalation of therapy. Now, radiology and echocardiography play an important role. So immediately after cannulation, we confirm it by echocardiography, ultrasound, or X-ray chest. And should be done once daily after stabilization or as and when required. Besides the cannula position, it also tells us about the lung condition or any complications like pneumothorax or infusion that may occur in an ECMO patient. Abdominal ultrasound is especially done prior to ECMO, especially in newborn or as and when required. These are according to the guidelines. The chest ultrasound should be done during ECMO. It helps in diagnosing the conditions like effusion and pneumothorax, as well as the position of the cannula. Head ultrasound should be done prior to ECMO, especially in newborns and after stabilizations. I personally have no experience in newborn ECMO, but these are according to the guidelines that I found. So 2D echo is done before starting of the ECMO. It can assess the baseline cardiac function. And in case of VA ECMO, we should do it more frequently. It helps in diagnosing many complications, and cannula position can also be checked by a transesophageal echocardiography. It can also look at the volume status when you look at the right atrium. And ideally, in all the ICUs nowadays, it is done practically once a day at least. The latest is the near infrared spectroscopy, which detects regional oxygen level of the brain tissue under light reflecting probes placed on the forehead of the patient. So it can check between the two sides and check for the regional oxygen saturation in the right and left hemispheres. The take home message and to summarize is you should have a checklist what to monitor, when to monitor. And you can modify it actually by the clinical setups and according to the patient and how sick is the patient, but a checklist is a must. And if you go in a particular sequence, it makes it much easier to not miss a thing. There can be many observations. There can be many observations that are seeing while monitoring the patient, and you should correlate them. Like if you have hypovolemia, you can see shattering, and then team training in simulation is a must. So the idea is to there's a separate talk on the life-threatening complication, and hence I didn't cover them in detail. But if you train the team in simulations and correlate observations, you can pick up many complications that are life-threatening much earlier. Thanks for patient listening.
Thank you, Dr. Saurabh, for the comprehensive explanation of the protocol for monitoring. It was quite useful. So, anybody else who would like to add anything or want to ask anything? I think we can close the session for today. It was very informative session. Dr. Rakesh, would you like to add anything? The closing remarks?
No, sir, I think Saurabh sir has covered everything from protocols to how important the protocols are. Nothing from my side.
Okay, so I think we close the session for today. It was a very informative session, and we'll join tomorrow at 5 p.m.
Thank you, Dr. Rakesh and Dr. Subir. Pleasure to be here. Yeah, thank you so much.
Thank you so much. We'll
Thank you,
join.
Dr. Kapil. Yeah. Bye.
Thank you. Thank you very much.
Thank you, sir.
Okay.
Ecmo.